In this exciting tutorial, we're going to be creating Pac-Man. For this tutorial, we'll be using pure JavaScript. That means no game frameworks or libraries. By doing this, we can learn the fundamentals of game development. If you understand everything that we do here, it'll make it much easier to understand gaming libraries in the future. Not only will we make Pac-Man, but we'll also learn a lot of modern JavaScript. As with all my tutorials, we'll start with a blank canvas and code every single part. No copy and pasting of large chunks of code here. This is the final game that we'll have by the end of this epic tutorial. As you can see, the game starts off paused. As soon as I hit an arrow key, Pac-Man starts to move and so do the enemies. You can hear that every single time he eats a pellet, there's a noise. Every time he moves, his mouth opens and closes, so he animates. I can't go through walls. Once I eat a power pellet, those ghosts turn blue. When it wears off, you can see the ghost is flashing blue and white. And then I can go around my level here. As you can see, I'm colliding into walls, nothing bad's happening. I can eat those pellets, and as soon as I eat that last pellet, it says you win. And it plays that iconic Pac-Man music that's normally at the beginning of the level, but I put it at the end of the level when you win. Then, if I collide into an enemy, I get game over. And also you'll notice that when I get game over or I win, it pauses the game so the enemies stop and I can see where I lost. So this is where I ran into the enemy when I got game over. And it plays some music as well. If you enjoy my tutorials, please subscribe, like, and share. Some of the topics that we're going to be covering in this video are creating a tile map. What you see over here, this level, that's a tile map. It's going to be 100% customizable from the code. You don't even have to create the same map that I create. You can create your own version of this map, any size. Also, it lets you the ability to add additional levels. So you could have multiple levels. Once you pass this level, maybe you go on to a new level that looks completely different. We also take keyboard input. So when Pac-Man moves, he moves in a continuous direction. If I hit left, he continues to move in that direction. If I hit down and then right, once he gets to the bottom, he will move right. I got lucky there and ate that ghost, by the way. There's animations. As Pac-Man moves, his mouth opens and closes. When we're in a new game like this, you can see that the power pellets flash pink and yellow. And then also the ghosts, as the power pellets wear off, they flash blue and white. So these are the animations that we'll be implementing. There's also collision detection. That ghost that I just ate, well, he ran into me. He collided with me and I ate him. This ghost, if I collide into him, well, that's a collision where I actually lose and Pac-Man dies. The other collision detection too are the walls. I can't go through any of these brick walls. There's also collision detection when I'm eating these pellets or eating power pellets. I'm detecting that collision and then doing something. When you eat a yellow pellet, I just make it disappear off the screen. When I collide into a ghost, well, you can die or you can eat them. Also, sound. Sound is extremely important. Anytime I go over a pellet, you hear a sound. When I run into a ghost, you hear sound, the game over music. So sound is extremely important for that immersiveness of your game. And our enemy AI. We're implementing a very simple enemy AI. They move randomly. Sometimes they look like they're chasing you. It's kind of like when you play music on shuffle and you think it's playing all your favorite music that day. It's just pure coincidence. And that's exactly what's happening here. Every once in a while, it looks like the enemies are chasing you, but they're not. It's just a random coincidence they happen to be going in that direction. Before we get started, this is what the final solution will look like. As you can see, we have several files to represent the different parts of the game here in our src directory. We have our enemy, we have Pac-Man, we have the game, moving direction as a utility, and the tile map that I spoke of, which builds out the level. All being driven through our index.html, which is our main entry point for our application. So as you can see over here, we're using index.html. And that is where everything runs through. And then we have a little bit of organization as well for our folders. So we've taken our code and put it into this src directory. We have a sounds directory for all the different sounds that we have within our application. And then we have our images as well. If we really wanted to, we could even make more directories inside images to represent the ghost or Pac-Man. But this, for now, for this smaller game, seems to work fairly well. For this tutorial, we're going to be using Visual Studio Code. If you don't have Visual Studio Code, just go to Google, type in Visual Studio Code, and go ahead and download it. Otherwise, you can use any editor for this tutorial. We're also using Chrome here. So I got Chrome on my right-hand side and Visual Studio over here. To get going, we're just going to want to open up a blank folder. To do that, we could just click Open inside Visual Studio Code. And then inside here, you can see I have Snake, Green Blob. These are previous tutorials that I've made. The great thing is that Green Blob is your introduction to game development. Snake takes it to the next level with just a little bit more complexity. And then Pac-Man takes it to an entirely new level. So what we'll do is from inside this folder, we'll just call this Pac-Man. I just made it all lowercase. Click Open, and then Visual Studio will open up to this new project that we have where we don't have any files yet. Let's get started by setting our project up. So first thing you could do is go ahead and close that welcome screen. I'm also going to click this button over here just so open editors don't appear here. And then underneath Pac-Man, what we'll do is we'll go ahead and start adding some files that we need. So click the new file button and we'll add index.html. And then we're going to add a folder called src. And then inside src, we're going to go ahead and add all these blank files that we don't have yet, but might as well add them anyways. So we're going to add an enemy.js. We're going to add Game.js. We'll add moving direction. So these are all things we haven't implemented yet. But what I want to do is create them all now so that we don't have to do it later. If you don't know what you're building, you wouldn't know these files, but because this is a tutorial that I prepared ahead of time, I can tell you exactly which files we need. So there's the files that we have. We have 5 files with no code inside them right now. So inside our index.html, we're going to kick off this HTML that we need. It's going to be very little HTML because most of the code is actually coming from the source code over here. Inside of our index.html, all we have to do really is put an exclamation like that. And then if you hit tab on your keyboard, it will create the HTML template for you. Then inside of the title, we can put Pac-Man just like that. And then inside of our body, we're just going to put some really simple HTML. And that really simple HTML that we're going to put is a div. Inside there, we'll put an h1. We'll put Pac-Man just like we did for our title. And then we're going to put a canvas. This is where our game is going to be drawn. So if we take a look at our canvas, we're going to add an ID. And that ID, we're just going to call it game canvas. And we're going to use this ID in the JavaScript in order to access this canvas and then draw to it. And then we're going to add a script file. We're going to start off by just adding the one script file. Our script file is located, so our index.html is outside the folder. Since it's outside the folder, we need to go inside that folder, src. And then inside src, we're going to get game.js. And then because we're going to be using something called imports and exports, we're going to have to call this type a module. Very important that we have this module here. So you need this type equals module for the rest of the code to work. And this kind of sets up our basic HTML. Next, we should display our HTML. We want to see that title Pac-Man over here on the left-hand side. And we could open up the index.html file locally on our computer. But I think a better way of doing it is to use something called Live Server. It's an extension for Visual Studio Code. And every time I click Save in Visual Studio Code, it'll refresh over here. It makes development so much faster. So to get that extension, go to extensions over here. In this box up above, type Live Server, find Live Server, and click Install. I have it installed, so my only option is to disable or uninstall. Then when we go back to our project, you're probably not going to have this button available right away when it's a new project. What you can do is you can right-click on the file and say Open with Live Server. Click that, and then over here, it'll open up the HTML that we're currently working on. To show you how this works, once it's already open, it's going to show us which port it's using. So we're using port 5500, and you can see that in our URL. It's 127001, which is our current computer. And then 5500 is the port, and the page that's opened is index.html. So to show how this works, if we just delete part of our title, instead of Pac-Man, it just says Pac, and then we undo that and then click save, you can see it just refreshes the screen automatically. Another quick little extension that you can install that I currently have installed is every time I click save, you see that it gets reformatted so that all the code looks nice. So go to extensions, look up prettier, find prettier code formatter, click install. And then once you have that installed, you got to do two things. One is go to settings, look up save, check that checkbox so it says format on save, then look for code formatter. And then what I've done on my machine, at least, is I've changed this drop down over here to say prettier code formatter. So then it uses prettier to format my documents. Then, just as I showed you, go back to our index.html and I add additional spaces or things like that, change the indentation, it changes it to match a very specific format. Now that we've got our live server running, our extensions installed, let's make this look a little bit nicer. Inside of our head, we're going to go ahead and add a style tag. So that style tag over here we'll add. And the first thing that we're going to format is our game canvas. So let's go ahead and add some formatting to our game canvas. As you can see, our game canvas has this identifier. So we use that identifier up here with a little hash in front of it to say that we're using the identifier. And then for the canvas, we're going to go ahead and add a box shadow. That box shadow, we're going to set to 10 pixels. 10 pixels. This is the position of where it's going to be. And 20 pixels. And then a color black. And then our box will appear here. So it's always been there. We just couldn't see it. But as soon as we added a shadow below it, kind of makes it pop up the screen and just gives it a nice visual effect. We can also style our body, and we're also going to style our H1. So let's start with that H1. It's a little simpler. For the H1, we're going to text align center. So now you can see it goes center. Then we're going to give it a different font. So the font that I want to give it is something a little bit more fun. The font is going to be Comic Sans. So let's look up Comic Sans MS. When I click save, you can see how that changed. If I get rid of that, you can see it changes. Because it's a game, this seems pretty appropriate. And then we're going to change the color because the background is going to be a dark color. So let's just make that light gray. Lastly, we'll go ahead and style our body. For the body, we're going to go ahead and add a few properties. One is we're going to display a flex. So right now, if we take a look at this, our canvas is always on the left-hand side. We want it to be centered. So we're going to use something called flex. So once I add the justify content center and the flex, then it becomes centered. Just like that. The other thing is, just in case scroll bars appear, I don't want them to take away from the game experience. So I'm just adding an overflow hidden. This is optional. Don't really need it, but just in case scroll bars appear. This is going to, for the height, we're going to send it to 100 vertical height. This is going to affect the background color. Now the background color, I don't know how to do this off the top of my head, but I normally look this up. And there's a lot of tools out there that let you kind of create a linear gradient, and they're all visual tools, and it's really great and real easy to use. So normally I would just copy and paste the values from there. What I have here is something that I kind of created earlier, but if you just change these numbers, you can get so many different effects, and I'll show you an easy way to change these after you type this in. So we're going from a blue color to this purple color, and let's just fill that in right there with these numbers. So basically we're saying start at 0% with blue, then go to purple. Now, if we want to change these, you can hover over these little colors inside Visual Studio Code, of course, and then we can go ahead and change this. So now this color becomes green, save it, and then our Pac-Man looks like this. So really cool how you can easily change it from here, and that's it. And then you can play around with these numbers if you wanted to as well, and provided you type it correctly, it'll do different things. So you can see that looks even cooler. Yeah, and that's just one way of setting up your linear gradient background. So now let's just kind of undo what we had there. We'll just kind of go with the sample that we had before with the purple and the white text. Now that we have our setup out of the way, we can focus on making our game. So in order to start programming, we're going to jump into Game.JS. So Game.JS over here in our SRC will be our entry point for our application. Inside Game.js, we're going to get a reference to our canvas. We'll define a constant called canvas, and we're going to find our canvas by the element ID. The element ID that we defined it as is game canvas. So game canvas, we're going to pass that into our get element by ID. I'm going to minimize this over here. And then what we're going to do is we need to get a reference to our context from the canvas. Simply achieved by going get context on our canvas, and we can ask for different kinds, 3D and 2D. So we're going to use 2D. And then we need to define a game loop. Now a game loop could be any function. I'm going to call it game loop. It could be called game. And what it's going to do is it's going to basically redraw the screen a certain number of times every 1 second. In order to achieve that, we're going to use something called setInterval. SetInterval calls a function every X period of time, and it takes in milliseconds. So we're going to take in 1,000 milliseconds, which is 1 second. And then we're going to divide by 75 so that we know that we can call this method 75 times every 1 second to redraw the screen. Now the game loop is the most important part of our application. It's going to run every single time to update the screen. So in order to show you how it's working, I do have my console open here, but to get to this console, you can go to 3 dots over here in Chrome, go to More Tools, and then go to Developer Tools. And that'll pop up your console. It might be on the left, right? Normally it pops up on the bottom, but if you want to put it in a different place, click the 3 dots on that, pop up, and then decide what location you want to put it at. Then click on the console tab over here. And then what we're going to do inside our application is we're just going to console log game loop so you can see that it's being called. And now in the console, you can see that we're calling game loop over and over. And this is happening 75 times every 1 second in order to refresh our screen. Next, we're going to build our tile map. So let's do a bit of that setup first. Inside of our game.js, we're going to want to call our tile map and get our tile map to draw the screen in our game loop. So the way we're going to do that is we're going to import something. So this is going to be the concept of modules and importing and exporting. And we're going to use it very simply. So in our tile map, if you don't know the syntax yet, you're going to learn it. So in our tile map, we're going to export a default item here. And we're going to export our class map. So tile map, we're creating a class called tile map. And then that tile map, we're just going to give it the bare description over here. It's going to have a constructor, and it's going to have a draw method. That doesn't do anything yet. And inside the draw, we'll just call draw. So we haven't done anything. We haven't drawn a tile map yet, but we define an empty method called draw. And one other piece of information that we're going to want to give to our tile map is how big each tile is going to be. So it's going to take in something called a tile size. So inside our constructor, we'll set up our tile size and we'll say that's equal to tile size. Now that we've exported this, we're going to import it. So if we go on over to our game over here, at the top of the screen, what we're going to do is we're going to do something called an import. And we're going to import the tile map from, and we give it the location of this item. So the location of this item is in the same directory. So we put a dot right there, and we say slash. Then it's the name of the file, tile map, and we use .js at the end. To make sure this is working, we're going to do the following. So after we've defined our canvas and our context, we'll define another value called tile map with a lowercase t is equal to new tile map. So we're going to initialize our tile map. And if you remember, our tile map has an item in its constructor called tile size. So in addition to that, we're going to define a tile size. We'll do that at the very top here. and we're going to say tile size is equal to 32. And I'll be explaining shortly why. We're going to pass in our tile size to our tile map, and then make sure everything is saved as well. And then over here in our tile map, what we're going to do, oh, little typo. So be careful to make sure you type everything right. You can see I got an error. Tile map is not defined at line 6. So over here at line 6, it's saying that this doesn't exist. And it doesn't exist because of the typo that I have over there. That M was a lowercase m, and now it's a capital M. Now you can see it's still printing my game loop, and it's working. So we know that part of our application is working. Always important to see any errors that you see in your console and fix them right away. Otherwise, you'll be fixing lots and lots of errors. You want to always kind of code in a good state. So then to make sure that this works, we can say tilemap.draw and call that function. And remember, inside the draw method, we printed out draw. So now that we can see that working, we know that our tile map is essentially doing something. All right, next step is to implement our tile map. So our tile map, I'm just going to comment out actually our draw method over here. I don't want that continuously printing. To implement our tile map, what is a tile map? Well, I have the original game right here. And the game is actually created with images, and each image is 32 pixels. Your images could be any size that you want, but that's the size that I've chosen here for this tile map. This is built basically with little squares. So each square is 32 pixels and contains a different image. At the top, we have about 13 bricks. Over here, we have 1 brick, and then we have a whole bunch of dots, and each dot is its own image as well, except it takes up, most of it is the little yellow in the middle, and the rest of it is the black. To better illustrate this, I've created an image, and what I've done is shown you that there's little blocks, and these little blocks are different little images, each one of these squares, just as I said. So there's roughly about 13 above. Then over here, there's the dots. You can see Pac-Man is its own image as well. That is 32 pixels. The power pellet is 32 pixels. So that's kind of what a tile map is. And you build a tile map using an array. So we're going to create an array inside our tile map that's going to define what the map looks like. And this will be completely configurable. And you'll be able to manipulate this to basically make your own maps, which could be any size. I've just chosen this number of blocks this way, this number of blocks that way. But you could add even more rows, make your columns have even more columns to make it as big and as complicated as you like. Let's get that code started for the tile map. So inside our tile map file, what we're going to do is we're going to define an array. We're going to call that array map. And then this array, right? This array is going to represent this entire array here. And then we're going to have rows. Okay, so we have an array of arrays. So each array, so let's go here. If we add another array, so we have brackets inside brackets, it looks a little confusing, but it's gonna be clear soon. What we're gonna do is we're gonna assign a number to say what each item is. So bricks will be number 1, pellets will be 0. So going back over here to our array, we know that the very top, it's all gonna be bricks. So it's all gonna be 1s. So what I'm gonna do here, just to match the example that I have, is I'll put about 13 of these 1s over here, just to match the example that I have. And one more. Okay, so far we've drawn the first row. The next row, so I'm gonna do over here is I'm just gonna expand this just so I can get inside here, is there's gonna be a second array. So we put a comma, and I'm gonna copy that one there. I'm gonna paste it. Now for this row over here, there's only 1 brick on the end and 1 brick on the end. Everything else, we're just going to make a 0 for now. So everything else is just going to be a pellet. So then what we can do to overwrite all of these here, one quick way would be to highlight the 1. Then on Mac, you would hit Command D and you'd see it adds all these cursors. If you're on Windows, hit Control D and just continue tapping it and it keeps adding a new cursor. Then you see I have all these cursors here that I can move in unison. I can then highlight the previous number, put 0, and then hit escape to make all those cursors go away. So now I have two rows. I built the first row and the second row. Now I'm not going to build out all of these the same. What we're going to do is we're going to start off with just a whole bunch of coins, and then we'll add the other bricks after. So we'll just do a few rows here. And then at the very bottom, what I'm going to do is I'm going to copy what we had at the top and then paste that at the bottom. So what we have here is you can see all ones all along the outside. So that's our walls. And then inside, we're just going to have pellets. So we'll just click save on that. And then our prettier formatter, if you set that up earlier, will format this really nicely so it's easier to look at. All right, so before we draw, let's go ahead and add a new folder called images. Click on index.html, then click that folder so it's on the outside of your src directory. Call it images, and I'm going to provide a way to download those images in the description. So for now, I'm just dragging in the ones that I need, and you'll be able to do the same from the description by getting those assets. So let's see, I'm going to go bring in a few images. We got our pink dot, our wall, and our yellow dot. If I click on those images, you can see it's just a 32-bit image. You can actually see that here at the bottom, Visual Studio 32 by 32. And yeah, it's just one image for the bricks, and it just comes together to make this cool brick structure around the end of our thing. And then the pink dot and the yellow dot, pink dot's slightly bigger than the yellow, that's for the animation. And then the yellow dot over here is obviously our pellets that we can eat. So step one of drawing our tile map. Inside of our tile map, inside the constructor over here, we're going to get some references to those images because we're going to need those. So we'll say this dot yellow dot is equal to a new image. And then we'll say this dot yellow dot src. So we want to set up the location of that images. So we are in this src. So we need to go up one directory. So go dot dot dot. Then we need to go inside the images directory. So we put images there. And then we go yellow dot, and it's yellow dot png. And then we need to set up our wall as well. So we say wall is equal to new image. Do the same thing. We say this dot wall dot src is equal to, and then slash images, and then wall dot png. And then we have our images set up. All right, before we can draw our canvas, the first thing we're going to want to do is to resize the canvas to fit whatever shape this is going to be. So if this is longer or shorter or whatever, we want this size to change. Right now, it's just whatever the default size is. So we're going to want to see that changing on our screen. So in order to do that, what we're going to do is we're going to define a method on our tile map. And we're just going to call this one time. So if we kind of go from the beginning of our application, we go to our game over here. Before we don't want to do this with every single game loop. There's no point. Might as well just set the size one time. So the way we can do this is we can ask our tile map. We're going to tell our tile map to set the size. And we're going to create a method called setCanvasSize. And setCanvasSize is going to take in the canvas itself. And then we'll get an error because it'll tell us that the method doesn't exist. So what we'll do is we'll copy that method name, go into our tile map, and you can put this method anywhere, but I'll put it here at the bottom. And we're going to set our canvas size. It's going to take in the canvas. And then all we have to do inside of this method over here is just set up the width and the height based on the length of our map. So to set up the width, we're going to have to look at each row. We have an array, but we want to look at like the first row because they should all be the same size and then build our canvas out to be that big. So in order to do that, we say canvas.width is equal to this.map, and then we're going to access that first row of data inside there. We're going to get its length, and then we'll say times this, and we know how big each tile is. Each tile is 32 pixels, so if we get the rows over here, and we know how many there are, we times it by 32, and then that will give us our width. So you can see that on my screen here, that my map actually got bigger there. So now it's like a rectangular shape like that. So let's get that height on there. So we can say canvas.height is equal to this. And now to get the height, we just need to know how many rows there are. To get the number of rows, we don't access the first item. We just say, how big is this array? How many rows does it contain? Well, that array will contain that times, and once again, we need to times the number of tiles there are, or the size of the tiles. And you can see that got bigger. If I delete a bunch of these rows, you don't have to do this, and then click save, you'll see that it just gets bigger and smaller. So this will allow us to create different level sizes and different complexities and allow our canvas to grow and fit that shape. All right, here's the exciting part. We are finally going to draw something to the screen. So let's do this. So inside our draw method, we're going to want to loop over our map. We're going to use the concept of rows and columns. So what we'll do is we'll define a row count over here, and we'll just say that's equal to 0. And we'll say, well, the row is less than this.map.length. So that's the number of arrays inside of our map over here. So from line 13 to 23. And then we'll just increment that row. Then inside of each row, we're going to loop over the number of items inside it. So that would be the array. So the first row we're going to loop over. We're going to say for let, and we're going to call that a column. And that column will be equal to 0, and that column will be less than this.map. And now we're accessing that row, and then we're getting the length of that row. And then we're going to go column plus plus. And then inside of that row, we're going to get the tile. So we're going to say each cell, like this, or this item here, is going to be called a tile. What we can do is we can say let tile equal to this.map.row, and then check this out. We use our columns. That nice little loops that we have here translate into getting this variable for us. We give it the row and we give it the column. Then we can take this tile and decide which kind of image to draw. So the value of this tile is going to be 1 or 0 right now. If the tile is equal to 1, we're going to draw our wall. And we'll use curly braces, just makes it a little bit easier to read. So we'll say this dot, and we're going to create a brand new method called draw wall. And I'm using this new notation with the hash over here to denote that this is a private method. It's no different if we do that, really. There won't be anything noticeable in our application. It's just a better way of writing code if you're like, this method should not be accessible, which means that technically in the game, if we went to the game over here, I shouldn't be able to call this over here. So I shouldn't be able to say tilemap.hash or whatever. It should not let me call any method that starts with the hash because it's private and should only be used internally. So going back to our tile map over here. So now we're going to draw that wall. Okay, so let's go ahead and implement that method. So it gives us an error letting us know that draw wall is not implemented. It doesn't really matter where you put it. I'll put it below the draw method, and we'll have a draw wall. And that draw wall is going to need some information. The information that we're going to pass the draw wall will be the CTX, the column, the row, and the size. And the size is just going to be this .tile size for now. So there's really no different size or anything that we're building here. So we're giving it the CTX, row, and column. So column first, then row, and then the tile size. So then we go over here, we have to define our function. So just the same things that we just typed up there. We have CTX, we have column, we have row, and we have something called size. Now, all we have to do is take that CTX and call draw image. And then inside of draw image, we're going to give it the image that we defined earlier, which is our wall. So we'll say this.wall. And then we have to give it over here, it says our X position. So our X position will be the column. So that's our left to right. And then we figure that out by using the tile size that we defined earlier. So that will position us in the right place. Then we take our row and we say this dot tile size. So same thing, we're setting up our Y position. And then the size of this image, we decided to just use that. So the size is going to be a width and a height. So we have to put that number in twice over here because our width and height will be the same. That's pretty amazing. We have something being drawn on the screen. So our walls are now being drawn, which is really, really cool. Next, we can go ahead and draw our pellets. So we can say else if the tile is equal to 0. Let's go ahead and draw our pellet or our dot. We'll call it a dot in our code here. So we'll just do another function called this dot and we'll give it the pound. Again, just making this private. We'll say this dot draw dot and we give it the CTX, we give it the column, we give it the row, and just in case we wanted things to be different sizes, we can pass this in. And then for our draw dot, we're going to do exactly the same thing. So if you really want, you can copy and paste that. If not, you can just type it out, but you can just probably copy and paste that. So draw dot, same thing, CTX, column, row, and the size. And then what we do is pretty much the same. And we're just going to say draw image and then say this dot yellow dot. And then we give it the column times this dot tile size. And then row times this dot tile size. And then we need to give it the size, so the width and the height, which are exactly the same. And then we save that. And we have our map. Not exactly the same map, but we have our map set up. Let's go ahead and make this map look a little bit nicer by adding more walls. So we have all the coins in the middle, so that's really, really cool. What we could do now is kind of like update our map to emulate something that we had in the original one, like this over here. I'm sure enough we could code probably some kind of editor or whatever. This is a form of an editor. But you could probably have something where you click, 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 and the numbers change or something like that. So what we'll do here is we'll kind of just quickly build this out. Build it out however you want, but I'll just show you a quick example of how I'm going to build it out. So I'm just going to, same trick here. I'm going to use Command D, or Control D on Windows. I'm going to change the value of these to 1 over here, just to make like a little column. And then what I'll do over here is probably just type these in because it's a little bit easier. And then I'll just type 1 over there and 1 over there and then 1 over there. So you have this nice little row, and then let's hit save to see what we got so far. And you can see we've started to build out our map. Hopefully you're doing this as well too. It's really cool just to see it being built out. And then along here, let's do exactly the same thing too. So what you could do is just put ones, oh, not there. That would be the wrong place. I was just about to put that. So every time I hit save, I could see the change. So there you go. We got a brick, brick, and then brick. So we're building like another little line there, kind of like the example that we had. Yeah, and we can kind of build this out however you want. I'll just pause here for a quick sec and build it out and be right back. All right, here's the final little example that I've created so far. I'll make sure to paste this into the description, so that if you want to just copy the one I have, but you probably won't want to because it's kind of fun to go ahead and just make your own. So give it a shot. It's just so cool to be able to change these numbers here and see that reflected here. One extra thing that we can do to visualize our tile map is just add a little bit of code in our tile map in the draw method. So in the draw method, what we're going to do is every single time we draw one of our tiles, we're going to draw a little border around each tile so we can actually visualize how it's adding these items. We'll use CTX and we're going to do something called a stroke style, and which just basically sets the color that we're going to use for our stroke, and we'll use yellow. Then what we do is we're going to draw a rectangle, but we're not going to do a fill rectangle. We're going to do a stroke rectangle, which means it'll draw an outline. And then all we have to do is give it the column. So we need the X position, which is column. will be this dot tile times tile size. Then we get the row with this dot tile size, so that finds our Y position to put it. And then we have to give it a size. So for this, we can just use this dot tile size and this dot tile size. Save that. And then look at this. We get a visualization of each and every single piece that we drew. So as we traverse over this for loop, we're going to go left to right. So first we draw this brick, then we draw the next brick, until we've drawn that entire row. Then we go ahead and draw the next row, where we draw a brick and then a dot and just continue going along that path. But now you can see how this map is broken into tiny little tiles, each representing a 32 by 32 square in order to draw this map. And then what we can do is we can just comment this out and leave this here for whenever we want to visualize how this map looks and where those little squares are. The next thing that we're going to focus on now that we have our tile map drawing to the screen is getting Pac-Man on the screen. Pac-Man is going to be a little bit complicated. There are a number of things that we need to do, which include displaying him, rotating him, collisions, but we'll break those down into small steps that we can achieve. So for the first thing that we want to achieve is displaying Pac-Man. Now, whenever we play Pac-Man, we can have different levels, and those different levels, Pac-Man could be in a different place, a different starting position. We'll start with that starting position in mind. And we're going to let our tile map help us with that. What we're going to do is inside of our tile map, we're going to define where Pac-Man starts. And once again, we'll just use a number for that. So in our little example over here, we'll get Pac-Man to start somewhere at the beginning of the level, and we're going to give it a number 4. We didn't define what happens if we don't know what a number is. So all of a sudden we get this blank spot on our screen where it didn't draw. That's actually really good that we're seeing that. What we're going to do over here is also in our code, we're just going to make a little legend. We're going to say 1. 1 is walls. 0 is, we'll just call them dots for now. And then man will be number 4. So that's where that dot is. Next is in our main application within our Game.JS, what we're going to want to do is define Pac-Man here. Because Pac-Man will have its own draw method in that, and we'll need a way to get Pac-Man. After we've defined our tile map, now our tile map is kind of dictating where Pac-Man comes from, so we'll also let the tile map create Pac-Man for us. So we'll create a constant called Pac-Man, and we're going to use tilemap.get, actually that's a capital, .get Pac-Man. And get Pac-Man will include some additional information that Pac-Man needs for its creation, which will be its velocity. And above or below our tile size, we'll just define one of these other parameters here called velocity. Maybe I'll put a gap between these kind of different components here that we have. So our velocity will be equal to 1. That's just how much Pac-Man will move every single time the screen gets updated during this game loop. This is going to let us know that the method is not implemented. What we will do then is we'll go into our tile map and we're going to implement that new method. We'll implement it below all the drawing stuff here. So we'll implement get Pac-Man here. And then get Pac-Man, as we mentioned, takes in a velocity, which is just some information it needs when it's constructed. And what we're going to do is we need to find where Pac-Man is before we can draw it. So we're just going to loop over our collection just like we did before. Very same thing. We're going to find all the rows. And then for each row, we're going to go ahead then and loop over the columns. And each one of those columns, we'll just do column is less than this dot map, and then the row dot length. Just a little bit repetitive, but looping over that. And then inside of that column, we get our cell, and our cell is our tile. So we say our tile is equal to this dot map, and we just give it the row, we give it the column, and then just do an if, and we say if the tile is equal to number 4, that, just number 4, we're going to get Pac-Man here. We're going to build Pac-Man actually. We'll return Pac-Man back to the user. So what we'll do over here is we're going to return a new Pac-Man object. To get Pac-Man, so Pac-Man doesn't exist just yet. One is we're going to need to import it. So this is back to our importing and exporting. So we're going to get something from another file. We need to import, and we're going to import Pac-Man from, and we're going to go current directory. So that's what dot means. And we're going to go to the pacman.js file. So that's the file that's over here. Then if we scroll on down to our method, we're returning Pac-Man. And then when we return Pac-Man as well, we're going to replace this spot on the map. So this spot on the map contained Pac-Man. If this spot on the map contains Pac-Man, we're going to set it to a dot. We're going to set it to 0. So if we, for example, get rid of this over here, and then we go to Pac-Man, we just need to do an export. So we're going to do the same thing here. We're going to export default Pac-Man, and then that needs to be a class. And then our curly braces at the end to define our class. Now, where Pac-Man was, that just got replaced. So let me show you over here. I'm going to get rid of this here. So we found Pac-Man's position, and then we're going to replace it with a pellet, because wherever Pac-Man starts, he'll also be starting on top of a pellet. So now we're going to return Pac-Man. Okay. And Pac-Man needs a bunch of information. It's going to need to know its X and Y position. So we can figure out the X and Y position by taking the column that we found and the row that we found, and then timesing it by this dot tile size. And then we do the same thing for the row. We say this dot tile, and I'll minimize that, dot tile size. Save that. And then the other thing that's going to know is how big is its tile. So it needs to know the size. So this dot tile size. And then it needs to know the velocity, which is that extra information that we passed in. And then we can also give it a reference to the tile map. So for future reference, Pac-Man will know about the tile map, so it can figure out if he's colliding with something. So this is a lot of information that we passed into Pac-Man. So what we can do here to make this easy to see is we can copy that just for now. And then we can head on over to the Pac-Man file. And then what we're going to do is this. I'm going to minimize that. And I'm just pasting this here. If you highlight everything and if you hit Control ? It will comment it out on a Windows machine. On a Mac machine, hit Command ? And it puts a comment like that because we don't need that information. And what we've done here is when we construct Pac-Man, we need these fields in it. So we go ahead and add constructor, and we know that's going to be the X position, the Y position. So that's the X is the column, the Y is that. Then there's going to be a size, or we can also call it tile size. And then there's the velocity, and then there's the tile map. So then all we have to do is set all those things up on our object. So we connect those things to our object. So we're connecting the X, connecting the Y, connecting the tile size is equal to tile size. Then there is the velocity as well that we need to connect. And lastly, this tile map. And now we can go ahead and delete this over here because we don't need it anymore. That was just for reference. Next, we're going to go ahead and copy in the images that we need to represent Pac-Man. We have 3 images to represent Pac-Man. Those three images are when Pac-Man's mouth is fully closed, Pac-Man's mouth is partially open, and then also when Pac-Man's mouth is completely open. And we'll also go ahead and add a draw method. That draw method will take in a CTX, just like that. And then back inside of our Game.JS, all we're going to do inside of our game loop after we draw the tile map is we're going to tell Pac-Man to go ahead and draw and pass in that CTX value. Now we can go ahead and start to load those images. So what we're going to do to load the images is we're going to create a little method over here. This method is going to be another private method. And we'll just call it load Pac-Man images right there. And then we can just copy that name there as well. Go define our function. We can define it after the draw. That method that we're going to define, we need to get references to our three different images that we have, Pac 0, 1, and 2. So the way that we're going to get reference to those images is we just do the same thing we did before. We define a constant. And we say Pac-Man image 1 is equal to new image. Pac-Man image 1.src is equal to wherever that image is. And that image is in images / pac0.png. Then we're going to define a few more of these. Actually, we're going to define 4. This is going to come back later when we're animating. But for now, we're going to define all of these images. So rename all of these appropriately. So I'm going to rename this to 2, and rename this one to 3, and I'll rename this one to 4. We just need to also rename these over here. Now, what about this? We only have 0, 1, and 2. Well, that very last image over there is going to be used when we do some looping for the animation, as we loop over the animation items. So I'm just going to define that as number 1, but it will make sense a little later on. But for now, you could start off with those 3 and then add the 4th one later, but I'd rather add them all now because it's going to be required for how we implement the implementation. Then the only thing that we really need to do is we need to just create an array of all these images. So all of these are just defined inside here with these const. But to attach it to the object, we have to use this. We use this.pacman images is equal to an array, and we give it the Pac-Man image 1, the Pac-Man image 2, Pac-Man image 3, and Pac-Man image 4. And then the only last piece of information that we're really going to need to know is which image are we currently using. So we'll call that Pac-Man image index, and we're going to set that to a number. We'll set it to 0. That's going to be the first image. We'll start with Pac-Man fully closed. So that's what we'll be using. Okay, so then the next step is that we actually need to draw. To draw Pac-Man, we're going to start with the simple way of doing it. So the simple way that we're going to draw Pac-Man to start off with, because later we're going to deal with rotations and changing Pac-Man. If you've noticed so far, the Pac-Man images that we have, they only face one direction. They're all facing right. We need them to go left, down, different directions. And that's what you saw in the Pac-Man game that we had earlier. But we're going to use one image and rotate it, which is going to be very, very interesting. Before we can do that, we need to just get Pac-Man drawn on the screen, and we need to get Pac-Man moving. So we're only going to worry about that later. So for now, go back to pacman.js. Inside the draw, it's going to take in a few things. So one is we have access to all our Pac-Man images, that array that we made before. Then inside that array, we're going to say access the Pac-Man image index. So that's the current image that we want to display. Just like the other ones, we need to give it the X position, the Y position. Let me actually minimize that. So X position, Y position. And after those ones, we need to give it the size. So we're just going to use this.tile size and this.tile size. So that's the size of Pac-Man. And then we get Pac-Man on the screen. If you want to show a different Pac-Man image, let's go into our load images, scroll on down, see the Pac-Man image index. Let's change that number. Change it to 1. His mouth is open. Change it to 2. His mouth is completely open. And you can see Remember we did think to draw the dot behind Pac-Man? Well, Pac-Man starts off with a dot already there. It's right there on the screen, which is kind of cool. You can see our image has also got some transparency on it because we can see behind Pac-Man to see that dot. Next, we're going to implement moving Pac-Man. So Pac-Man's kind of interesting in how he moves. So if we take this diagram over here, if we told Pac-Man to start moving left over here, he would be moving in this direction. As soon as, if he's on top of these bricks over here and we hit down while he's moving left, he's not going to go down. He's going to continue to move left until he gets to an empty space. Then he'll move down. So his current direction will be left, and then requested direction will be down, which means we need to keep track of two variables for Pac-Man's movement: the current direction and the requested direction. That's something we'll be doing now as we implement Pac-Man moving on the screen. To get Pac-Man moving, we're going to set up a few things. One of those things is we created a file earlier called moving direction. So let's go finally implement that, because we're going to be using these values to track the direction that Pac-Man is going in. What this is simply going to be is just an object called moving direction, and it's just going to have several properties. It's going to have an up represented by 0, a down represented by 1, left represented by 2, and a right represented by 3. And I mistyped that one over there, so that's 2. Then all we have to do with this value that we create over here, just like we've done in the other files, is we need to export it. So we'll just export the moving direction. Inside of Pac-Man, what we're going to do is at the top of that file, we're going to import it. So Pac-Man file is going to use the moving direction. So we'll just do import moving direction. My autofill over here, but if you're typing it out, from, and then dot, and then slash moving direction. Remember, dot means the current directory. That file is in the same directory as Pac-Man, so all I have to do is just put a dot, a slash, and then the name of the file. So the only thing I'm missing here is the .js errors right now, so I'll just also open up our console here just to make sure that we're not getting any errors. So we're all good at the moment. So what we'll do now, and make sure you click save on your files so that you're not getting an error. Make sure you don't have an error, and let's continue. As I mentioned before, Pac-Man's going to have a current moving direction and a requested moving direction. So let's go implement that. Go to Pac-Man. We'll go to our constructor, and inside our constructor, we'll just add those values. I'm going to add that after these initializations over here. I'm going to say this .current moving direction is equal to null, so we're just going to say it's empty, and this dot requested moving direction. You can see these variables are very descriptive so that you know exactly what they do. What we're going to do is we need to take keyboard input. So now what we're going to do is access the document, and we are going to add an event listener. We're going to listen for any events for the keyboard. And we're going to listen to a particular one called key down, and make sure that this is key down with a lower d, and I'll hide this over here. Key down with a lower d, very important, so that event fires. And we're going to create a brand new method that doesn't exist yet called key down. It's the same name as that, except we have a hash in front of it, meaning that it's a private method. To make these things just a little easier here, we'll just collapse. Really nice being able to collapse your code so it's easier to see. Below here, we'll just continue putting all our private methods at the bottom. We'll add a new one called keydown. And the keydown function does take a parameter inside of it, and that's going to be the event. We'll write our function like such. Actually, and we're gonna make this an arrow function. The reason for that is we don't want this to be the wrong thing. We want this to always be equal to Pac-Man. That may be a new concept. So anyhow, we're going to take in an event, and we're using an arrow function over here. Inside of our arrow function, when it gets executed, This will always represent the Pac-Man object, so we have access to these variables. If we weren't doing that, then there's a good chance that this will be equal to the DOM element who's invoking the key down method. Now, all we want to do is capture all our different events. We want to capture our key code. So when a keyboard event fires, we need a key code, and the key code number 38 is actually equal to our up arrow. You could also map these to your WASD keys, the WASD, which traditionally you use for gaming. But I'm going to hook it up to the arrow keys, so it's a little bit more old school that way. So here we go. We got our key code. We're going to get our up key, and we're just going to implement all the keys here. So I'm just duplicating these lines over here. And we're going to do line 40 is going to be our down key. 30, let's see what the next one is, 37. So 37 is left, and then 39 is right. So I'm just adding comments above them so we know exactly which key is which key. So we got all of those saved there, prettier, formatted a little bit nicer. And now once we've done this, we can start to actually capture that input and do something with these moving directions that we have. What we're going to do next is actually set the variable for the current moving direction and the requested moving direction. So inside of our up over here, what we're going to do is we're going to say if this.current moving direction is equal to the moving direction that we imported. So we'll say moving direction dot down. Then what we're going to say is this dot current moving direction will be equal to moving direction dot up. So what we're doing here is if you're already moving in the down direction, you can switch to the up direction. So we're going to switch your moving direction to up. Otherwise, we're just going to leave it. So let's go ahead and do that. And then we'll say this dot requested moving direction is going to be equal to moving direction dot up. So this is the direction that you're going to request. Like I said, if you're moving down, it's okay to switch to up. But if you're moving in a different direction, well, we're going to check the requested direction and then maybe set it if you're allowed to move. So Pac-Man's movements is a little bit more complicated than other parts of the game. And then this pattern that we have here, we would repeat for the down, the left, and the right. So you're allowed to go the opposite direction, but if you're already moving right and you request to move up, we don't want to move you right away. We're going to do a check later to see if there's a collision, a wall in the way, before you're allowed to move in that direction. For the down, we're going to do exactly the same thing. So what we can do is we can actually copy this over here. And then inside of the down, we can say if your current moving direction is up, then you're allowed to go down because you're already moving in that direction. Then your requested direction is going to be down like that. Then we can copy this again and we implement the same thing for left. So if we say if your current direction is going right, then you're allowed to go left because clearly you've moved away from the left area. If not, we're going to capture the fact that you want to move left, but you haven't been allowed to move left yet because maybe there's something in the way. And then we do exactly the same thing again for the right. If you're moving left currently and you request to move right, that's okay with us. You can go ahead and do that because you were on the right side. If not, if you were moving up or down and all of a sudden you asked to move right, we're going to check. This comes into play when Pac-Man is moving. Here's Pac-Man here. If he starts to move left and I hit down, well, we're going to say that's your requested direction because I can't move down yet, but once I get here, I'm allowed to move down. If I'm moving left right now and I hit the right key over here, because my current direction is left and I just requested to move right, well, I know that there was empty space on the side. So of course, Let's go ahead and just automatically set your moving direction to right. And then you can start to move in the right direction. To get Pac-Man moving, we're going to implement a method called move. So if we scroll on up to the draw method, we're going to go ahead and add a brand new method called move. And move will be in charge of moving Pac-Man. I'm just getting a little typo error there. And then we're going to implement this new method. Might as well put it with the rest of our methods down here that are all private. I'm going to collapse that. And we'll add this move method. And move, there are a few things that we're going to do with Pac-Man. One, before we get Pac-Man moving, I'm going to head on over to the tile map. And earlier we implemented some code that I'm going to uncomment. Have this code right now. Feel free to type it out. But what this is doing is it's overlaying our tile map with a grid. When Pac-Man moves, he never really moves in between a grid item. He's going to move all the way inside of a grid. So in order to figure that out, we'll have to do a little bit of math. Fortunately, the math is pretty simple. We're just going to figure out if Pac-Man wants to move down, he can't move halfway through a square. You have to move when you're perfectly aligned within one of our 32 by 32 squares. So let's go ahead back to Pac-Man, and I'll minimize that there. And inside our move method, let's implement this logic. First thing we're going to do is we're going to check whether or not we can change or set the direction of Pac-Man. When Pac-Man starts, if I hit any key right now on the keyboard, what's going to happen is the requested move direction is going to be set, but the current move direction will never be set. So the first thing that we need to do is to check if the current moving direction, which is going to be null initially, is equal to this dot requested moving direction. If it is, first we need to check if Pac-Man's current position using number is an even number divisible by 32. So we're just going to check if the number is an integer, if it has no decimal points. And the way we're going to do this is we're going to take the X position and divide it by the tile size. And we're going to check the X position and the Y position. Essentially, I go ahead and do the same thing here. I go number.isInteger, and I give it this.y, and then we divide by this.tile size, and if I hit save, we can see we're doing this division over here. And if that is true, then what we're going to do is we're going to say the current moving direction is allowed to be set to the requested moving direction. When that happens, so this is just our first kind of block of code inside here to get the current direction all set up. With that set up, we can then implement a switch statement. So this switch statement will take in the current moving direction. Then depending on the direction it's moving in, it's going to increase or decrease Pac-Man's X or Y so that it begins to move on the screen. Over here on the switch, let's do one at a time. We're going to use that moving direction value. So the way this works, we pass in the current direction, and then we say, hey, is this instance over here equal to up? If it is equal to the up, then what we're going to do is we're going to say, oops, let me get rid of that typo. We're going to say this.y. And the way the grid works is if your Y position is here, if you want to move up, you go negative. If you want to move down, you go positive. Because the coordinates of one of these grids is 0, 0 over here. So X and Y are 0. Then to move X this way, you go positive, go negative. So here we go. So we're going to use our Y, and we're going to say Y is equal to minus equal this dot velocity. And our velocity currently is set to 1, I believe. So we'll go ahead and save that. Now, if I hit up over here, our Pac-Man starts to move. That's incredible. Let's get this example going a little bit better. Now we're just going to grab the Y position, and we're going to do the same thing for the down. So for that down, we're just going to put down inside there, and then we're going to plus on the Y. So now let's go give this a try. So now when I push down on Pac-Man, he'll go down. If I push up, he'll go up because that requested direction. So remember, if I'm going down and I push up, it'll immediately change directions because we don't need to do that check to make sure you're in a perfect little 32 by 32 space, not in between something before you can move, because we're just going to go the opposite direction. Now let's go get those other cases down. So we're going to do left and right. So if you're moving left, we're changing the X position. So this dot X, and we do minus our velocity. So we should move in the opposite direction. And then our right, when you're moving right, it's going to be a positive number because you're going right. So since it's a positive number, we just take that X and we say plus equals. And then over here, when I move, I can move. If I hit down, it'll only go down when it's inside of that grid. It's not something you typically notice unless you have this little grid here. And it looks like I'm moving along the walls, but we haven't implemented collision detection yet. And our Pac-Man is moving a little bit slow. So to speed up his movement, we can go to our game where we defined a velocity. So this velocity, let's just double it. Doubling that velocity, yes, yeah, that's much better. Now our Pac-Man moves really fast, a bit more of a fast-paced game. I can pretend that there's collision detection by trying to avoid those walls. Eventually when we hit down, Pac-Man will move the way he's intended to. So right now, if I were to hit down, and this isn't going to work, but let's pretend I hit down. He should only move when he gets to that end. And the same thing here. That's why we have the requested direction. We're going to check for collisions, and we're going to make sure Pac-Man also can't exit the game area like he just did right now. Next, we're going to implement collision detection. How we're going to implement collision detection is inside Pac-Man, when we're moving, and you request a different direction, a direction that's not equal to the current direction. The only way that we can set or change your current direction is if you're not going to collide into something. So if you're moving, let's say left over here, and I push down, it won't let me go down until I get to the end over here. Right now, if I push it, it'll just go down automatically. So that's kind of what we want to do. We want to check. So entire time we're moving left, we're going to say, am I colliding with something when I push down? Am I colliding? Am I colliding? Am I colliding? Until I get to here and we're not colliding with something. So in order to do that, we're going to need a check. And that check that we're going to put is over here. Once we see that it's a positive integer value, an even value, we're going to check, hey, is this a brick? Is this a brick? And the way that we do that is we're going to ask the tile map. We're going to leverage the tile map to ask a question. We're going to say, hey, tile map, did I collide with the environment? We say did collide with environment, Pac-Man's X position, Pac-Man's Y position, and the direction that Pac-Man wants to go in. So the requested moving direction. I'll save that so it's a little easier to read. So first we do the if statement to see if we're inside a positive area. Then, since I pushed down, we'll say for my example here, we'll check if there's something to collide with. Now we haven't implemented this method yet, but remember we take the tile map inside our constructor. That was the reason that Pac-Man knows about the tile map. It's so that Pac-Man can say, hey, are we going to collide with something before I change my moving direction? So over here we said this.tile map did collide with environment. If we did not, so that's what the exclamation is for, if we did not collide with the environment, then what happens is we can change the moving direction. Right now, if I click save and I try this, it's broken, so it's not working. So now we'll go ahead and implement this method inside the tile map. Let's implement did collide with environment. I'm going to copy the name from Pac-Man.js over here. I'm going to go to my tile map, and I've kind of just minimized all these methods over here. And then I'm going to add did collide with environment here. It has an X, a Y, and a direction. And then what we're going to do is we need to use the moving direction over here. I'm going to go ahead and import moving direction. One thing to note, it just automatically imported here for me. It might not do that for you. I have some other extensions installed. But just dot slash then moving direction for the current directory, and make sure to put that JS at the end. If you don't put that JS, you're going to get an error saying that I can't find that file. So just add that JS there. Then inside did collide with environment, we're going to do the following. One, we only want to execute this method if you're inside of one of these squares. To check if you're inside one of those squares, we do that same check that we did before, where we say number.isInteger, and we take the x and we divide it by the tile size to figure out whether or not it's a decimal number. And we do the same thing for the y as well. Then if once we're good over there and we are inside a square, this is where we'll just do a little bit of work to go ahead and figure out inside the tile map which row and column we are inside here. And then what's that number? Is it a 0? Is it a 1? Is it a brick? Is it not a brick? Basically, we want to know if there's a collision with something. So the way we're going to achieve that, we'll set up several variables over here. We're going to set up the row. We're using a case statement, so we'll have to set up another variable called next column. And we'll also set one up for next row, and we'll just set all these variables to 0, and you'll see how we use them over here in our switch statement. Our switch statement will take in the direction that comes from our method. Using that switch statement, we're just going to set up a few of these. We're going to do that using that import. We're going to set these up. So we'll start with right. So if our case is right, we're going to figure out our next column. And our next column, so if I'm moving right over here and Pac-Man was stopped over here, then our next column would be this brick over here. So that's a positive number. It's moving to the next direction. So we're going to take the X position, say this dot tile size. Then we're going to figure out which column we are inside the array. And we're going to say column is equal to next column divided by this dot tile size. So we moved Pac-Man over 1 to the right to check its position, then divided it to get what that number is inside of our array. And then the row is basically just going to be using that y divided by this dot tile size. And then we always put a break at the end of our case because we don't want the next case to be executed, no point. And then what we're going to do is we're going to copy that. And then for the left, we do exactly the same thing. For the left over here, the only difference is when you're moving left, it's a negative on the grid. Then we can go ahead and kind of copy and paste this we'll just copy and paste the right one that we had. And we'll rename this one over here to up. And remember, when you move up, you actually move negative. This over here, we're going to look up the next row is what we're actually interested in. We should have just deleted all of that. That might be easier. So the next row is going to be equal to y minus this tile size, which means the row next row will be equal to this divided by tile size. So we have our tile size, and then the column kind of becomes like the other ones where we just use x divided by this dot tile size. And then don't forget that equal over there. And then this one's a little easier to copy and paste because all we have to do is just reverse the sign over there. So we'll change that from a negative to a plus. Don't forget to change this part over here to down. Now that we have this data, using the column and the row, we can figure out which tile you are inside this map. And the way we do that is we just tile equal to this dot map. We give it the row, we give it the column. And then once we have that, we say if tile, if it's equal to 1, that means we are colliding with a wall. Since we're colliding with a wall and the method name is did collide with environment, we return true. Otherwise, we're going to return false at the very end of our if statement over here. So at the very end of our if statement, after that curly brace, we return false. So right now there's a little bit of an error so that when Pac-Man can go through walls, he may not always follow as a direction and sometimes can go through walls, as you can see. To resolve that error, what we need to do is we need to go into Pac-Man. And before we can move, like this movement always happens no matter what. Before we move Pac-Man, we should check if there's a collision. So now we're going to do additional collision check, where we'll say, did you collide with the environment? And we're going to say this.x, this.y. And then lastly, instead of the requested moving direction, this is the current moving direction. And then if you did collide, we're just going to return. So you're not allowed to move anymore. Now, if we go back to Pac-Man and we start moving around, we shouldn't collide into any walls. So here's my classic example. I'm going to go left. Now I push down. As soon as I get to the end, he moves down. I push right, he moves that way. So it's listening for that requested direction, only executing the requested direction if we're in a place that allows us to move. And now we have Pac-Man moving on the screen. Let's go ahead and animate Pac-Man. So in the draw method of the Pac-Man file, we're going to add a new function called animate. The job of animate will be to animate Pac-Man to open and close the mouth. And we're going to be using these images that we created earlier. We're going to loop over this array and one by one show the mouth opening and closing. And we're going to use a timer to do that. A timer that starts at 10, counts down to 0, and as soon as it gets to 0, it switches from one image to another, restarts the timer at 10, and then does the same thing again. Now, the reason that we created this array of 4 images is in this one, Pac-Man's mouth is completely closed. Partially open, completely open, and then to make the transition when his mouth is open all the way to opening just part of the way, I created another variable called Pac-Man image 4. That's the same as 1, but at least in our array over here, it'll follow that order to closed, partially open, completely open, and then partially open, and then closing the mouth. So it's this nice little transition between the different images. So let's go ahead and add that timer. So in our constructor, we'll go ahead and add the Pac-Man Animation timer, and we're going to set one variable is going to be called a default, and the other one's going to be the one that actually counts down. So the animation timer by default will be equal to null. We'll go down into our animation over here. What we're going to do with our animation is first we're going to check whether or not that value is null. If that value is null, then we will not do anything. Then the animation timer won't do a thing. So we'll just say if this dot Pac-Man animation timer is equal to null, then don't do anything. So we just do null and we do return like that. So nothing happens. So then the next thing we need to do is we need to take that Pac-Man animation timer and minus it. So this is the value that starts at 10. And so the first pass of this loop will reduce it to 9. But once the next time we call this method and the value is equal to 0, that means we need to change which image we're showing for Pac-Man. So we see it's equal to 0. And then once it's equal to 0, we're also going to do a little administrative work of resetting that timer back to 10. So the next time we call it, we'll just do that and say it's equal to 10 again. So we use that default value so that we can easily change the value in the future to make it slower or faster. Then what we do is we increment the image that we're using. So remember, up over here in the draw method of Pac-Man, so let's just go up. So we'll minimize move, minimize the images. Up over here in Pac-Man, to select the image, we use the image index. So we just go to the next image in the list. Once we get to the end of that list, we'll just want to go back to image 0. So once we get to the end, and the end will be equal to the Pac-Man images.length, Once it's equal to that, just go ahead and simply set that Pac-Man image index back to 0, so it restarts the animation. The reason Pac-Man's not animating yet is that value is actually set to null by default in our constructor, so nothing is going to happen. So our move method will be the one who kind of controls when we're animating. And the important part of our move is after we do these initial checks for the requested direction and we're working with the current moving direction, this is where we'll do a little check. So after this if, we'll do an else if, and we're going to check if we have a moving direction. So we're going to say the current moving direction does not equal null. If the current moving direction doesn't equal null, and this .Pac-Man Animation frame timer is equal to null, equal to null, then what we can do, let me make sure I got this right over here. Looks a little bit messy, but give it a second. What we can do then, and we'll just move our switch down a little bit. For inside this else if over here, that means our moving direction, we got one, we are moving, and our Pac-Man animation frame is equal to null. If that's the situation, then we're going to say Pac-Man animation frame timer, you're equal to the default value. Now you can see why the default value is useful, is we use it in multiple places. We use it here on line 113, and then later on down, we also use it in the animate method to reset the value. If I was trying to remember those values, I'd have to put 10 here and 10 there. If I changed 1 to 5, then all of a sudden you'll get some weird animations depending on what's happening. Now, when our Pac-Man moves, he starts animating, and he doesn't rotate yet. That's for later. But the one thing we also want to do is we want Pac-Man to stop animating when Pac-Man runs into a wall. Taking a look at our Pac-Man over here and our move method, and we look at our collide. So when we collide, this is where we can stop that animation. So we can say the Pac-Man animation timer will be equal to null. And then we can also say the Pac-Man animation image index is equal to 1, because I want you to stop on a particular thing. Now you notice our Pac-Man opened his mouth when we started, even though it's supposed to start on image 0. Now that's because of a bug in our did collide with environment. And this is easy to fix. We just can go to our tile map over here. And right now we have a direction. So we can say if the direction is equal to null, because when we first start using this, we don't have a direction. If the direction is equal to null, return. If we return, now Pac-Man's mouth will be closed again. This method was returning the wrong value. What was happening was it was passing in 0 here, and a current moving direction of null, and then it thought that there was a wall, which is not even our current location. That's why we did that little fix there. So anyhow, Pac-Man now starts in the right position. When Pac-Man starts moving, Pac-Man will animate, opening, closing its mouth. We did this little thing over here to set a particular image. Otherwise, it'll be kind of random what Pac-Man gets. So let's go and collide into a wall and see what happens. So it's partially open. It's all the way open. It's like that. It looks kind of funny when Pac-Man just does different things. I just forced Pac-Man to have his mouth partially open when Pac-Man collides into a wall, no matter which wall Pac-Man is colliding into. And now we have Pac-Man animating as Pac-Man moves. So one of the things that we're going to do next is rotate Pac-Man. But just to make this look a little bit nicer, let's go back to our tile map. And if we go back to our tile map file over here, let's just remove, if you have this on, I'm going to remove the code that goes ahead and actually adds that extra little yellow line around everything. And there you are. Now we can have Pac-Man here in our actual game animating. So Pac-Man's animating. Other cool thing that you can do just real quick is if we remove drawing the bricks and we just keep the outlines, you can see this cool little grid that we got here. You can't see where the walls are, so it's like playing Invisible Pac-Man. And then Pac-Man, we're not really redrawing the background. So you get this really interesting thing here. If I can remember exactly what the level looks like, I can kind of traverse around it, as you can see. So kind of a neat little thing, how you can accidentally create games while creating Pac-Man. Well, let's just go ahead and undo what we had over here. And also get rid of those yellow lines. And now what we're going to do is we want Pac-Man to actually rotate. So instead of using images that face left, down, up, whatever, we're going to actually rotate the image so that Pac-Man, when he's going left, is facing left, and when he's going down, he's facing down and up, and all those. Right now, he's only facing the right direction and animating in that direction. But to achieve that, we're going to be making changes in our Pac-Man file. And then inside of our Pac-Man file, we're going to create a new variable inside here. So we're going to create some variable called rotation. Rotation is going to be this thing that just tracks our values and lets us use words over here. So we're going to do right, down. So down will be 1, left will be 2, and up will be 3. And then we'll create another value inside our constructor. So inside our constructor, we're going to do a Pac-Man rotation. Pac-Man rotation by default will be equal to this dot rotation dot right. So we're using that new variable that we just added over here to assign a value over here. It makes it easy to use switch statements if we decide to. Let's go ahead and jump into our move. We're going to track that rotation. So let's go ahead and start doing that over here. So the Pac-Man rotation that we just set up, if you're moving up, means our rotation will be equal to up as well. Let's do this dot rotation dot up. And then we'll do exactly the same thing for all these other directions that we have. So the Pac-Man rotation will be equal to this dot rotation dot down. Exactly the same thing for the left. We got our rotation dot left. We only got one more to go here. Just gonna copy and paste that one. See how I'm missing that semicolon, but as soon as I click save, because of prettier, it adds it in. That's really, really nice. Now, I'm not gonna lie, but this next part is just a little bit complicated. What we're going to do is we're going to modify our draw method over here, and we're going to do some fairly complex stuff with the canvas. It's not a lot of code like we just had before. It's just complicated code, but I wouldn't worry too much about it. In theory, if you really wanted to, you could have different images for the different directions, but this is a novel way of reusing the images that you have in order to have Pac-Man face different directions, or even your enemies if you decided to. So what we'll do here is we'll just minimize everything that we're not using. And in the draw method, we're no longer going to be, we're going to be drawing like this, but we're going to pass in some different variables. So I'll comment that out for the time being, because we're not going to be using that. And this is what we're going to do. So over here, I'm going to define a variable called size. And my size will be equal to half that of my tile, so divided by 2. Then what we're going to do using this, we're going to take our CTX, so that's our context, represents this canvas. And we're going to save the current state. The current state right now would be this size with this information on it. So we're going to call a method called save. Now we're going to take that canvas and we're going to translate it. So let's do a translate. So basically we're telling the canvas the X and Y positions are going to be different. They're going to be found in a different way. Then we're going to take our canvas and we're actually going to flip the entire canvas. We're going to rotate this whole canvas right here. So we're going to say rotate. Inside here, we're going to do a little bit of math. So we're going to say this. So I'm putting an extra bracket that you saw here. And what we're going to do is we're going to say this dot Pac-Man rotation, okay, times. So these numbers are important actually. These numbers that I set up above for the Pac-Man rotation in our rotation variable, they must be 0, 1, 2, and 3. Don't use any other values. So then we're going to times 90 degrees. And then we're going to times math with a capital pi. Divide that by 180. And I'm not kidding, this is complicated. Look at the weird stuff that's already happening now. Our canvas is getting rotated and translated, and the background that we're drawing, or tile map, is kind of getting messed up. But not to worry. The next thing that we do is we want to draw our image, and now we're going to draw our Pac-Man. So this part is the same as before. We're going to go to our Pac-Man images. We're going to say this dot Pac-Man image index. Find the image that we want. And now here's the part that I don't quite understand as well, but we do minus size, and if you recall, those are half the tile size. And then we say this dot tile size and this dot tile size. And I'll save that so that it formats it better. So then Pac-Man will be drawn on the screen still, as you can see. Because we translate, which says the X and Y position start, instead of X and Y starting here, they might start here, or here, or here, depending on the number of degrees that we rotate our canvas. Then when we draw Pac-Man, we're drawing him from a different perspective because we've flipped this whole thing around. Really hard to understand. Then we draw Pac-Man, and then at the very end, we say, okay, rotate everything back to where it was. So we say ctx dot restore. This save over here saves the state it was here, and then we restore that state at the end, so it comes back. And then our board comes back. But now, if we move Pac-Man that way and that way, he changes directions. All of that code does this little code over here, does that little bit of magic to rotate our image. In a future video, I'll try better to explain this with a lot more diagrams and pictures. For simplicity's sake and building Pac-Man, it's not quite as important, as you could really just use different images to animate and show this. But this lets you use 4 images, or 3 images actually, for Pac-Man, and we don't have to recreate that. It's kind of neat. I go left, I go right, Pac-Man's facing that direction. Once you do this yourself, you'll see how cool it is and how neat to have Pac-Man going in these different directions. Now that we have Pac-Man animating and moving, the next logical step is to go ahead and eat those dots. When we eat a dot, we're also going to make a sound. So in order to implement this, we're going to open up our Pac-Man.js file. And then in the draw method, we're going to add another method that we're going to call. And we're going to call eat dot. We'll make that lowercase right there. Inside of eat dot, we'll go implement that at the bottom. And we're doing it as a private method once again. What we're going to do here is we're going to do an if statement. And Pac-Man's not really responsible for eating the dot. Pac-Man's going to ask the tile map to eat a dot for it. And if a dot is eaten, then it'll make it disappear from the screen. So the way this is going to happen is we'll do an if statement. And the reason for the if is if a dot is eaten, we're going to play a sound. So that's what we plan to do. Then we're going to say this dot tile map dot eat dot. We're going to do it based on Pac-Man's current position. So Pac-Man's current position will be its X and Y coordinates. And that's all we have to do over here for Pac-Man, is call this method. And then inside of tile map, actually before we move on, you'll notice that in Pac-Man eat dot is private because only Pac-Man calls that method. But eat dot for tile map is public, so we don't have that little hash in front of it. It's only on this method for Pac-Man, but eat dot on tile map, well, we need to expose it so that Pac-Man can use it. So then we'll go into the tile map and we're going to implement that method. We'll just put that at the bottom as well. So I'm just going to minimize did collide and we'll put eat dot over here. And then eat dot, what we're going to do is we're going to have to look at the tile map and then figure out whether or not that X and Y position is equal to a tile that has a dot on it. As you saw, we take in an X and we take in a Y. And then what we're going to do is we're going to figure out the column and the row. So the way we figure out the column and the row from the X and Y is we take the Y, we divide it by this dot tile size. To figure out the column, we take the X position, divide that by this dot tile size. Then what we do is we check if those numbers are integers, because we need to make sure that you're actually in a square. The collision detection that we're going to use is Pac-Man needs to be directly on top of the dot and then it's eaten. This is a really simple form of collision detection. You could detect if you're halfway through a dot, but the form we're going to use right here is just to make sure that you're directly on it. So really simple form. And then later on, when we do enemy and player hits, we're going to do a little bit more complicated form of collision detection. So let's do it this way, is integer. We're going to check if the row is an integer, and we're going to check if the column is also an integer. So give it the column. If they are integers, then we're going to use those numbers to go ahead and figure out if this dot map, give it the row, give it the column, that's going to give us back a number. And if that number is equal to 1, then we know that we've landed on top of a dot, because we defined our map as such so that, 1 are walls and 0 are dots. So if it's equal to 0, so if we've landed on a dot, we might want to flip that to something that's a blank space. So far we said 0 are dots for Pac-Man. So we'll say that 5 is an empty space. So that's what 5 will be. So then we'll go down over here. So when Pac-Man lands on something that's a 0, we're going to take this exact position that's over here, this .map.row.column, and we'll go ahead and we're going to set its value to 5, which should set it to an empty space as we go over it. So right now it's not doing that. This is actually really kind of cool. It looks like it's leaving the previous drawn Pac-Man there because we don't overwrite it. But I have to say, that looks amazing. It's kind of cool. Like I mentioned earlier, the mistakes that you make actually end up looking really, really neat, and you end up creating something you didn't expect. So this, I think, is actually really, really cool. But that's not really what we want. So we need to go into our draw method over here. And look, we're checking if a tile is equal to 1. We're checking if a tile is equal to 0. But when something's not one of those, we leave whatever we drew earlier. And we drew Pac-Man as Pac-Man was moving across that area. So remember, Pac-Man increments slowly across the screen. You just don't see it because it's refreshing really quickly. So you get this kind of ghosting effect, especially here. And then when you go over the second time, it looks even more interesting. To solve this problem, what we could do is we could over here say else, like a final else over here. And that final else will basically just draw a black rectangle. This dot draw, and we're going to do draw blank. We'll create a private function that does that for us. And we'll give it the ctx, the column, the row, and this dot tile size. Then we'll do the same thing that we did for our wall. So we'll just implement another method. We'll say draw blank, and we'll give it the ctx, the column, the row, and the size. And then for this one, we're not using, like this one we used ctx.drawImage, but we're actually going to draw to the screen over here. So we'll go ahead and say ctx.fillStyle is equal to black. So this is kind of like our paintbrush. And then we're going to say ctx fill rectangle. And we have to give it the X and Y position. So as always, go column times this dot tile size. And then our row times this dot column size or tile size. And then we have to give it the width and the height. So we're just going to use size, and then save it. And then when we go over each item, it's now drawing a black rectangle. So if you wanted to, instead of black, just to illustrate it, we could draw, say, green and just save that. And now you can see it's drawing green like that. So anytime we go over one of these spots, it draws a green spot. But we're going to keep it as black because that makes it look like it's disappearing. And then let's just go double check here. So when we draw a blank, we're good. And then if we go to our eat dot, we also expected this to return a true or a false. But what we're going to do is if we eat a dot, we're going to return true. And if we don't eat a dot, we'll just return false. What we can do is just do it on the outside. If we go inside this if statement and we eventually do find a dot that's equal to 0, we'll go ahead and flip that map so that all of a sudden, or that map, that area, so that it becomes a blank spot. We could also use null. Instead of 5, you could put null, but I'm putting 5 there in case you actually intentionally wanted to, within your map, draw some blank spots. You could put 5. Putting null would just get a little bit messy. So right now we're tracking these things just with these variables. You could change these variables into well-defined variables if you wanted to, but the map is just really nice when you use single digits because it's really easy to look at and see where the dots are and where the walls are. And there you go. Now our Pac-Man is eating the dots on the screen. So next, we're going to add a little bit of sound to this. Before we can add sound, we're going to go ahead and add a brand new folder. So clicking on index.html and clicking that new folder button will make sure that it's on the same level as images and src. We'll go ahead and add sound, and then I'm going to drag over the waka sound over here, which is the waka waka sound that Pac-Man makes. And the description will tell you how you can get the different assets. Once we have the sound over here, we can go to Pac-Man.js. And in the constructor, we're going to define a new variable. This variable is going to represent the sound. So I'm going to call this waka sound, and waka sound is going to be equal to something called an audio object. The audio object will let us play a sound. So what we're going to do here is I'm going to go to that directory. You need to go back a directory, then into sounds, and then we can get the waka.wave. So it needs to be the same name as here. Then we can save that. In order to use this sound, all we need to do is go down to where we eat the dot. And remember, if we eat a dot, the eat dot method will return true, which means we can do something. So that thing that we're going to do is play the waka sound. So the variable that we just named is called waka sound. So right down here, we'll go this dot waka sound. In order to play it, we just need to call the method play. And now we should have sound. So every time we go over one of those dots, it makes the waka waka noise. If we go over a blank space, it doesn't make any noise, but going over the dots will make a noise. Because this method over here returns true, we then play the sound. Before we continue, I'm going to go ahead and comment out the sound for now. You can leave the sound in your game, but for my game, I'm going to leave it commented out since I'll be moving around a lot and that noise could become annoying. So I'll just get rid of that for a little bit. The next part of the application that we're going to be focusing on is the enemies. We're going to go ahead and create our enemies in a similar fashion to how we create Pac-Man. If we go to our Game.js, you'll notice that Pac-Man is created by the tile map. We call tilemap.getPacman. If we take a look at our tile map, you'll see that Pac-Man is actually positioned on the tile map to be over here. I could change Pac-Man's position over here by setting it to 4. There should only ever be 1, so I'm just going to remove the other. And now Pac-Man's position changes. So we're going to do exactly the same thing with our enemies. So we'll add a brand new comment here to identify that our enemies will be number 6, and this will be an enemy. And then the enemy over here, we'll just place a few of them on the screen. I'm going to put one in the corner over here, one in the corner over here, and since Pac-Man's over here, I guess it'll probably be pretty good to have 2 here. And let's put 1 right there as well, just to make it a little bit more difficult. So these are the areas where the enemies will be. Since we don't know what we're drawing at the moment, we just said, hey, if we don't know what it is, put a blank space there. And that's why we have a blank space right now, because we haven't identified what 6 is yet. But then in our Game.js, what we need to do over here is define a constant. We're going to make a variable called enemies, which will be equal to our tilemap.getEnemies. And this is going to be returning an array. This array that gets returned, we could loop over each enemy and then call draw. But a shortcut that we could use is we could call for each. So this for each takes in a function or a lambda that gets called for each enemy. So what we're going to do is we're going to give it a lambda expression like this. And we're just going to call draw on each enemy. And as we do with the draw, we always pass in the CTX so that it can actually do that drawing. Now, when I click save here, the map will be broken because we don't have an enemy and we don't have a draw method. So we have a few things that we need to implement. We'll start by jumping into the tile map and implementing the get enemies. So inside our tile map, we'll go add a brand new method called getEnemies. So let me just clean this up over here and hide the sidebar. Right around get Pac-Man, let's go ahead and add that getEnemies. Doesn't really matter where you add it. And remember, getEnemies also takes in a velocity. Now we're going to follow the same pattern we did with Pac-Man, where we need to basically get the row, the column, and then find out where these items are. The one difference for this method that we're writing, and we could do some reusability here, but why not? Let's just go ahead and write that code. But in your own code, remember, you could go ahead and just refactor this to some kind of common solution between the two methods. But essentially, this is how it's going to work. We're going to say let our row equal to 0. And then we're going to say row is less than this dot map dot length, and then row plus plus. And then once we get our row, we can go ahead and get our column, and then our column will be equal to 0. Our column will be less than this dot map. We give it the row, and then the length of that row. We're going to get all the columns inside there, and then column plus plus. And then once we're inside there, what we can do is go ahead and get our tile. Our tile we can define as a const since we're not changing it. And we'll say this dot map. So we can simply do the thing that we always do and get our column, our row, and our column, and that will give us our tile. And then what we want to do is we want to check if our tile is an enemy. And remember, if we go up over here, enemies will be number 6. So we're going to look for number 6. We're going to say if our tile is equal to 6, then we can do something with it. So we'll go ahead, say column, and then we're going to put that dot there. We're going to say dots equal to 0, because if you remember, we look at our diagram over here, dots are equal to 0. And since that dot is equal to 0, we just set that particular position within the tile map to 0. And then what we're going to want to do is we want to grab our enemies. So we're going to have our list of enemies over here, and we're going to push on a new enemy. We don't have an enemy yet, so we're going to have to go ahead and implement an enemy. But I know that an enemy will take in an X and Y position. So the X and Y will be based on your column and row. So that's going to be our row times tile size, our column times tile size, which will give us the X position over here and the Y position over here. We're also going to give it the size. So we're going to give it the tile size. We also need a velocity. And we're also going to give the enemy a reference to the map, which is something similar that we did to Pac-Man as well. After we've collected all of the enemies and replaced the enemies with dots, we're going to go ahead and then return that at the end of this for loop. So I'm just going to highlight the bracket over here to figure out where the for loop ends. And it looks like it ends right here. So at the very end of this for loop, we can return enemies. If we decided not to add any enemies to our tile map, then we would just return an empty list of enemies, and we would never draw any to the screen. We're still going to have an error, and our next step is going to go ahead and implement an enemy. So we don't have any enemies at the moment. So let's go implement an actual enemy. First thing we're going to want to do inside of our tile map right now is go ahead and import the enemy, even though it doesn't exist right now. So I'm going to put this between these two, but it doesn't really matter where you put the import here at the top. We're going to import the enemy from, and we're going to use the current directory and enemy.js. So inside here, we got our enemy.js file, and we're importing that. Then inside our enemy class, we still need to export something. So you can see we get that error over here that request module does not provide an export name default. We're going to do export default class enemy, and that class enemy over here. So now we'll satisfy that error, but our enemy still doesn't have a draw method. We could add a draw method right now. We'll just go ahead and add that draw method. Not going to do anything, but it gets rid of our error message for now. The next step that we'll do is we'll go ahead and implement the constructor. Back in our tile map where we have our enemy, we've gone ahead and defined kind of the constructor. So we have an X position, a Y position, a tile size, a velocity, and a reference back to the map. So let's go ahead and implement that. So we'll start by creating that constructor, and the constructor takes the X, the Y, Then we go back over here. It takes our tile size, velocity. So tile size, velocity, and the tile map itself. Then we have to do what we typically do inside our constructor over here. So I'll just close that up. And then this dot x is equal to x, and this dot y is equal to y, and this dot tile size is equal to tile size. And then this dot velocity is equal to our velocity. And the same thing for the tile map. It's quite a bit of setup, but there we go. And then is equal to the tile map. Now let's go ahead and load the ghost images before we draw to the screen. So I'm going to create a private function called load images, and we'll put that below our draw over here. And load images, we'll go ahead and load several different images. So these images, once again, I'll be providing them in the description and also in the full project. I'll go ahead and just copy these images over because I don't have them in my current project. So we have several different images to represent our ghost. Our ghost is going to be represented by the ghost image, which is just green, as you can see right there. And it's a 32 by 32 pixel image that I drew myself. And then there's also the scared ghost. The scared ghost will turn blue with pink eyes. When it's kind of losing its scared state and you can't eat it anymore, it'll flash between white and blue. So back and forth, it'll flash between these two, animating, letting you know that if you try and eat it, you might die because it'll change back to the green color where it's a normal ghost. So let's go ahead and implement using these images inside our enemy. So we have our load images over here, and we're just going to load several different variables. We're going to call one of them just the normal ghost. So this is the normal state of the ghost. And we'll just load an image. Oops, little typo there. And this .normal ghost.src is equal to, and then we just go into our images directory and we grab that ghost.png. And then we do the same thing for, we're going to call this one scared ghost is equal to new image dot scared ghost dot src is equal to images slash scared ghost dot png. And then we'll do the same thing for our second scared ghost. So we'll just copy and paste those lines and put them there. And then we'll just change this to 2. And this one is scared ghost 2, like that. Not a very original name, but it works. And then what we're going to do is for the current image of the ghost, we're going to have a property just called image. So this is the current image, and the current image will be normal ghost. And we'll flip between these other ones in just a little bit to see what they look like. Now we can go ahead and implement the draw method. So for draw, we're going to take in our CTX, because if you recall, inside our game over here, we pass CTX to the draw method. And then back inside our enemy over here, all we want to do is CTX dot draw image. We'll do this dot image, not scared, but image. And then this dot X, this dot Y, and this, and we'll just minimize this for a sec here. This dot tile size. And then lastly, we also need the tile size again, because that's the width, the height, the X and Y position, and the image. And then we click save, and we have ghosts on the screen. If you want to try out our other images to make sure they're working, we can put this dot scared ghost, and we should get blue. And then scared ghost 2, we should get the white ghost there. So there we go. We have all our images working for the ghosts. Next, we're going to look at moving our ghosts on the screen. First thing we could do is switch our ghost back to the normal ghosts. And then inside our constructor, what we're going to do is set up a couple of properties that we need to achieve moving our ghosts. We're going to be using a timer to change the direction our ghosts. Now all the ghosts are going to move differently. So they'll have different timers. So while one moves up, the other could all of a sudden change its direction, and each of them will appear to be moving differently because we'll have some random numbers generated. Just like Pac-Man, we're going to need to import the moving direction, and we're just going to import that from the current directory. And remember to put the JS at the end over there, and we don't have any errors. So good always to save and double check that you don't have any errors. Then what we're going to do is we'll set up this dot move direction. The move direction will be equal to, actually we'll call that moving direction. The moving direction will be equal to math.floor. So we're going to do some random here. We're going to randomly select the moving direction that the ghost starts with. So we're going to do that over here by doing math.random. And what we want to do is times it by the number of items there are in the moving direction. Now, the moving direction is an object, and it's an object of key value pairs. So there is this handy JavaScript method called object.keys, which can get us the up, down, left, right key. And then that'll tell us that there's 4 items in the list. So that's why we name them 0, 1, 2, 3, kind of like it's an array. So what we're going to do back inside our enemy is we'll use this nice little handy JavaScript method, because we're going to use math.random times 4, then round it down, and they'll give us a random number between 0 and 4. So not including 4, so it'll go 0, 1, 2, 3. Those will be one of the numbers that we get. So over here, we're going to say object, that's a capital over there, object.keys, and we give it the moving direction object. So this is the object up here. And then we just ask for the length, which will return 4. So that will give us a random moving direction for each of the ghosts. Then we're also going to set up 2 other properties, a direction timer default. So this will be the default value for our timer. Now we don't want the timer to be the same, because then that would mean that every single ghost would change its direction at the same time. So we'll do something random, and we'll do it between 2 numbers. So this method doesn't exist. We called it random, and I'll make that private as well. So just a little typo there. So this dot random. So let's go ahead and implement a random function. So we're doing random between 2 numbers. So we'll implement another private method, and we'll call it random. The random function will go ahead and take a min and a max value. So for example, our min here is 10 and our max is 50. And then what we're going to do with that is we're going to return math.floor and math.random. And what we do is we say times the max minus the min plus 1 plus min right there. And we have to actually move that min outside the math.floor. So there you go. That's a little hard to follow, but math.floor encompasses all of this over here. And then we add min. So this will give us the value between 10 and 50 for our ghosts. Let's go ahead and implement moving our enemies. So we'll start by creating a private method called move. This move method over here that we're going to define will move our enemies based on the current moving direction. So what we'll do is we need to first check if, well, there's a collision. And we can do that using our tile map. We actually made a generic method called didCollide with environment. If we want to make sure we don't misspell that, we can go to our tile map, look for the didCollide method, and there it is. And it's a pretty generic method. It takes in an X position, a Y position, and the moving direction, and then checks for a collision. So going back to our enemy over here and using that function, we can go ahead and give it the current X position, the Y position, and this dot moving direction. And then if we don't, that's why we put a not over here. If we don't have a collision, we can go ahead and move our enemy. To move our enemy, we're going to use a switch statement just like we do with Pac-Man. And we'll give it this dot moving direction. Then we can build several cases over here. We'll start with moving direction dot up. And then for moving direction up, what we do for that, if you recall, is the Y needs to be minus. So then we do velocity like that. and then we do a break. And then we build another case for moving direction dot down. And for that, you're going to do positive for the y. So this dot y plus equals this dot velocity, and then do a break. And then we'll do another case for moving direction dot left. And left is also going to be a negative direction. So minus equals our this dot velocity, and then we do a break as well. And our very last case, if we really want, we could just copy that, paste that in, format it a little bit nicer, and then that is our right, and right is a positive direction for the x, and then save it. Now you can see these two enemies moved in the same way. I'm going to hit refresh on the screen here and we'll get different results. So they must have tried to move left or down. That one's moving up. And now they all moved in unison, which is kind of cool. So we'll see different behaviors. Some of them are colliding with walls, so they're not moving. If they had timers set up, they'll change directions. And that is moving our enemies. Next, we're going to go ahead and implementing changing the direction of the enemies. Just in case it wasn't clear, I was hitting refresh on my keyboard in order to show the enemies moving. They only move once right now, but as soon as we implement the change direction using the timer, the enemies will continue to move on the screen. Let's go ahead and implement the change direction. So we're going to do that in our draw method. Right after the move, we'll go ahead and call a method called change direction. And that's going to go ahead and use that timer that we spoke about. We'll just minimize the move for now and these other methods just to keep the screen a little bit more cleaner. And we'll go ahead and add change direction. And change direction doesn't take any parameters in. Inside change direction, what we're going to do is first decrement the timer. Then we'll check the timer to see if it's at 0 and then go ahead and do something. So we'll go our direction timer minus minus to reduce that number. I'm also going to declare a variable called new move direction. And we'll just set that to null initially. Let's see, the first thing we're going to do is say, is the direction timer equal to 0? If the direction is equal to 0, we're going to do what we always do, and we're going to go ahead and reset that timer, and then do an action, and this action will be to change the direction. So to simply do that, we're going to go ahead and say the new move direction is equal to exactly the same code that we wrote above in our constructor. We'll just go ahead and redo that here. So all we're going to do is math.floor and then math.random and then do that time object.keys to get the number of items that we have inside our moving direction, which is equal to 4. But instead of hard coding in that to 4, we're going to get it directly from that object, just in case we decide to add other moving directions in the future. Next, what we're going to do is inside the change direction over here, we're going to check if we have a new moving direction. So if the new moving direction does get set, we're going to do a little if statement over here to say if the new moving direction does not equal to null. And we'll say if this dot current moving direction, so the direction the enemy is moving in, is not equal to the new move direction. Basically what this is guarding against is the fact that we got a new moving direction. So that means we got into this if statement. And then what we're doing is we're checking if the enemy is not already moving in the same direction. What this prevents is the fact that an enemy is going into a wall and keeps on trying to go into a wall and just never stops doing that. So what we do over here is we prevent that. Then what we're going to do before we even change your moving direction is we're going to check that your X and your Y position are within a grid. So you can only change directions if you're perfectly within one of these grids. So we're going to do that same check that we've done before with Pac-Man before we can move, which is checking the number is an integer for the Y and for the X when we divide that by the tile size. So we'll do exactly the same thing for the Y over here. This dot Y divided by this dot tile size. And then if that's good, then the next thing that we can do is check if there's a collision. So we'll do another if statement, and we'll say if this dot tile map, because remember a tile map has the collision check on it, and all we have to do is give it the X, the Y, and the new move direction. So we'll type that in over there, new move direction. And then if that is good and there wasn't a collision, what we're going to do is go ahead and say this dot move direction, or moving direction, is equal to the new move direction. So now the enemies will continue to move on the screen, and they'll move kind of randomly. You can see they're not really getting stuck in the walls. They do stay sometimes more towards the outside, so it depends where the enemies are. As remember, this is just really simple, basic AI for enemies. So they will randomly move, and sometimes they may not gravitate as much to the middle, but they'll stay on the outsides and keep you guessing as you move around. If you want more of a challenge with your enemies, instead of using 10 and 15 over here for your min and your max, you can just go ahead and use 1 and 3. And then you'll notice that the enemies really kind of start to move around sporadically. I'll even hit refresh there so we can see a little bit differently. So as I move around and I'm trying not to get hit, it's hard. You can see there I got hit a bunch of times. They're a lot more random this way, and they do sometimes go more up into these middle areas from what I could see with the current logic that we're using. Of course, you can implement a lot more complicated logic for your enemies, but this is the simplest way to get it going. Let's go ahead and implement some pause logic for our enemies. When the game first starts, the enemies shouldn't be moving. If they were, then they could kill you before you even start the game. So in order to do that, we're going to go to our Game.JS, and what our goal is to do is pass pause into our enemy. We'll just have a little function called pause, and this function that we're going to implement will do the following. So we'll call pause, and what pause does, at least initially, eventually we're going to implement this for game win and game over, but for now, what we're going to do is we're going to ask the Pac-Man object if Pac-Man made the first move. Made first move means Pac-Man started to move. So as soon as Pac-Man starts to move, the enemies should start to move. So let's go ahead and do that. I'm going to save this file. Then I'm going to go into the Pac-Man.js over here, and I'll go add a property called made first move. So inside the constructor over here, go ahead and add made first move, and we're going to set that equal to false, like that. As soon as any key is pressed, and it's for one of the directions that our game supports, we'll go ahead and set the first move equal to true. We can go into our key down method over here, so it's just at the bottom of the file for our Pac-Man. And then inside of each and every single one of these if statements that we over here, what we could do simply is say this dot made first move is equal to true. And we can just do the same thing in every single one of these if statements. These probably could be refactored to some common code, but for this simple example right now, this is probably the easiest right now to understand and see that we're setting this on every single key press that we listen for. Then the last step is inside of our enemy.js. As you remember, in our game.js, we're passing that pause method inside our draw method if it's not pause. So let's get to that draw method that we have inside of our enemy over here. And we're going to pass in a value over here called pause. And what we'll do is we'll just do a little if statement, and we'll say if it's not paused, then go ahead and execute the following two methods. I'm going to just cut them. So we're going to move these two methods over here into the pause logic. Now when we restart our game, the enemies won't move, but as soon as Pac-Man's made the first move in our game.js over here, this will become true, and then it won't be paused anymore. and our enemies will start to move when we move. To continue the theme of working with our ghosts, the next thing that we're going to do is we're going to implement the power dot. If a Pac-Man eats a power dot, then the ghosts will flash blue and white, and they'll be vulnerable to Pac-Man eating them. The power dot will be implemented inside the tile map. So once again, we're going to go back to our map over here, and we're going to define a new number to represent the power dot on the map. So let's go with number 7 will be equal to a power dot. And we'll sprinkle a few of these power dots on our map. So we'll put one over here in the corner, one over here, and then perhaps we'll put one in the middle of the screen as well. So we'll put one over here. So now if I click save, we'll see these empty spots where our power dots will be. So I'll be able to get one there, there, and there. Next, what we'll do is we'll go inside our draw method. And if we find a tile that's equal to 7, then we're going to go ahead and draw a power dot. So let's go ahead and do that over here. And we'll just do it after this last else statement here, because we always want that one to be there to draw a blank dot like we just did right now. And we'll go ahead and we'll say else if the tile is equal to 7, and we'll just make a brand new function that's private once again called draw power dot, and then we'll go ahead and implement that method. So right now we're getting an error message that says power dot doesn't exist. So we'll go ahead and implement that method. Just scroll down over here. I'll just collapse a few of these. I'm going to keep all these draw methods together. I'll just go ahead and put it after the dot, and we'll call that draw power dot. Then our power dot should be just like our other ones and take in the same values. So we can take in the CTX, the column, the row, and the tile size. I don't copy paste often, but might as well do it there. So we have those values being passed in, and then we'll define our function down over here with those values, and we have our CTX, our column, our row, and our tile size. So now we're not getting an error anymore. Now it's not drawing anything, so we're getting the background that's on our screen. So we're just getting the purple there, because now it's entering this method saying draw and nothing happens. So we just get the background of our application. Our power dot is going to be represented by our yellow dot over here and our pink dot. We want it to flash on the screen. Since it's going to flash on the screen, we're going to use that same concept of a timer. Back up in our constructor, what we're going to do is go ahead and define that timer, and we'll give it a default value and a timer value. So just like we've done before, we're going to go ahead and say this dot power dot animation timer is, we'll set the default actually. Default will be equal to 30. And then we'll have that same value here, but just without the default. And we're going to say this is equal to this dot power animation default there. The other thing we need is our image. So we have the yellow dot, but we don't have the pink dot. We can go ahead and get that image. So we'll get the pink dot and we'll say it's equal to a new image. And then we'll do this dot pink dot src is equal to, and then dot images pink dot png. Then what we can do is go ahead, we can actually test this real quick to make sure that it works. So I can say this dot yellow dot is equal to this dot pink dot. And then if I look at the screen, all the yellow dots turn to pink dots. So that means that I have this reference correct and that it's working. But I'm going to delete that because we don't need that. Since they're going to flash between them, we're going to define a variable called power dot. And to start off with, it's going to be equal to the pink dot. And then we're going to use this timer to switch to a yellow dot and a pink dot every 30 ticks. We're going to do that. So now we can go ahead and implement the power dot draw method. So we can go down to the draw method for the power dot, So inside of here, first thing we're going to want to do is take that timer that we have and -1 from it. Then, as soon as we call this method and the power.animation timer is equal to 0, then the first thing that we always do is we reset that timer. So this power.animation timer is equal to this power.animation timer default, so it sets it back to 30. After we've set it back to 30, what we're going to want to do is check which image is set to. So if the power dot current image is the pink image, then we're going to switch it to the yellow image. So we say this dot power dot is equal to this dot yellow dot. So we're going to switch it from pink to yellow. Otherwise, we'll just do a little if else statement over here, and we'll say this dot power dot is equal to this dot pink dot. We'll save that there. And then the last thing that we need to do is once we've done this little image switch over here, we always display it. So we use that CTX and we call draw image. We say this dot power dot, which is either going to be a yellow one or a pink one. And then we call column times this dot tile size and row times this dot tile size. Actually, instead of tile size works. So we could just use this variable actually instead. I'm going to rename this to size just to make it a little bit cleaner. So just quick little refactoring here to make this a little bit cleaner code. So we can just use size there and size over here as well. And then the last two variables that you could pass in are the size and size. If you don't, then it'll just use the size that's there. But there you go. Now we have our power dots flashing. If you want to make them slower or faster, you can go ahead and change this timer. So now they flash a little bit slower. If you want it to be ultra quick, then you could have something like that. So it depends whatever style you're kind of going for in your game. I kind of like the 30, but feel free to play with that and choose any number that you want. Now let's go ahead and get Pac-Man to eat one of these power dots. Right now, Pac-Man can't eat a power dot. So we're going to go ahead and open up the Pac-Man JS. Inside Pac-Man JS, inside the draw method, you can see we have the eat dot. So now we're going to have the eat power dot. So the power dot, we're going to implement that at this bottom of this page over here. Eat power dot over here. And what we're going to do is we're going to delegate to the tile map. So we'll go tile map dot eat power dot, and we're going to give it Pac-Man's X position and Y position. That will allow us to check Pac-Man's position and see if Pac-Man is on top of a power dot. We're also going to be returning true or false if Pac-Man's eaten a dot. If Pac-Man has eaten a dot, the ghosts will become blue. They'll turn into their scared state. Let's go into our tile map and implement eat power dot. So within our tile map, we'll just go to the bottom of the tile map. I'm going to put it beside eat dot because it seems like a logical place. And we give it the X and Y position. And then within here, what we're going to do is we're going to use the X to get the column and Y to get the row. We'll define our row is equal to Y divided by this dot tile size. And then we'll do const column equals X divided by this dot tile size. So that gives us our column and row. Then we're going to double check as Pac-Man moves. We always want to make sure that he's within a grid. But we'll go ahead and we'll just do a little if statement here, and we'll do is integer and give it the row, and then number dot is integer and give it the column. Then if that is true, what we can do is we can get the tile. So we can say the tile is equal to this dot map and give it the row and then give it the column. Once we have the tile, we can check if that tile is equal to the power dot. And our power dot we defined as number 7. So let's go ahead over here and say if tile map or tile is equal to 7, then what we're going to do is go ahead and set that part of the map as being blank. So we'll say this.map, row, column, and then we'll say that is equal to, and we'll do exactly what we did for the eat dot as well. Over here, we set it to 5 as being blank, and I believe we might have defined that up top, which is an empty space. So 5 over here will be an empty space, and then we'll just say return true. Otherwise, we're always just going to return false, which means that a power dot hasn't been eaten. So now when Pac-Man goes over a power dot, it gets eaten. So now that we've eaten a power dot, we'll have to do something with it. Let's start by playing a sound when Pac-Man goes over a power dot. So in order to do that, we're going to go and add a new sound. You may already have this sound if you got the project or if you've downloaded the resources. So over here for sound, I'm going to pull in power dot wave, and that power dot wave will be the sound that is played when we go over one of the power dots. So within Pac-Man.js, we'll go ahead and we'll set up a sound variable that we're going to be using. Just like our Waka sound, we're going to go have a power.sound. So let's go ahead and implement that next to our audio over here for the Waka, and we'll just call this .power.sound is equal to new audio, and it's just like the other one, so ... and then /sounds/power.wave. And then once we have our sound over here, which I think I misspelled, there we go, just missing. So it's always good to have your console open, as you could see. And now that I know I have no errors, I know that the power dot is working for the sound. Then we can go down to our method over here, and what we'll do is we'll say this.power.sound, and if we have gone over a dot, we're going to play that sound. And then every time we go over one of those dots, there should be a sound being played, and there we go. So let's go get that last one over there. The ghosts aren't turning blue just yet, but they will be soon. Now that we have a sound playing, we're going to go ahead and set up a few variables for Pac-Man. One of them is going to be a variable that's going to indicate that the power dot is active, and one variable is going to indicate that the power dot is about to expire. So what I'm going to do right now is within my constructor, I'll go set up the default values for those variables. So we'll just do that. It doesn't really matter where in your constructor. Perhaps we can do it just after the sound over here, just so it's all together with the power dots. We can say this.power.active is going to be equal to false by default because it's not active. And then the power dot about to expire, we're going to set that to false as well. So these two things will cause different things to happen. If the power dot is active, these guys will be blue. If the power dot is about to expire, the ghost will flash white and blue. Now back in the eat power dot method, we're going to go ahead and use these variables. So we're playing the sound. I'll delete that comment. And then what we're going to do is we're going to set the power dot active equal to true. And then this dot power dot about to expire will be equal to false. So if you click one power dot and you continue moving along and these guys start flashing blue, but all of a sudden you hit another power dot, then they should turn back to blue. So that's why we set this to true and then this to false in case they're already flashing blue and we want to reset that state. Now, what we're going to do is we're going to have a list of timers. And these timers that we're going to set up, so we're going to be using the set timeout method. The first thing we're going to do is if we have any timers, what we're going to do is go ahead and clear them. We're going to be using the set timeout method, and the set timeout method for each timer has essentially a way to stop the timer if you want to stop it. So there's this method called clear timeout, and you give it a timer. So essentially, we're going to have a list of timers. I know, not super clear right now, but you'll see in a second what this means. Once we've cleared all the timers, we're going to clear this array, which will be a list of timers. And there's only two timers we're ever going to have. One is going to be a timer that's going to count down from 6 seconds to say these guys are blue. Then there'll be another timer that activates about 3 seconds in to basically say, hey, we're halfway through the enemy being scared and they're about to turn back to regular enemies. So watch out, Pac-Man. In order to implement this, what we're going to do is we're using our timers over here. We're going to keep a list of these timers and we're going to push a timer on. The first thing we're going to do is we're going to implement, we'll do this one. We'll do let, and we'll do power.timer is going to be equal to set timeout. And our set timeout will do the following. So set timeout takes in a function that'll execute once a certain amount of time has gone by. And that certain amount of time over here is going to be 6 seconds. This thing takes in milliseconds, which we do 1,000, which is 1 second, times 6, so that'll give us 6 seconds. And then when those 6 seconds are done, what we're going to do is we're going to say this.power.active is equal to false. And we'll say this.power.about-to-expire is also set to false. Then we're going to take that power.timer and push it onto this list of timers. And then when this method finishes and comes back into the method, and someone's like, oh, we ate another power dot. Okay, well, first, get rid of this timer. And the way we get rid of it is by looping over this timers. Now, we're going to have one more timer that we're going to add. So we're going to say let the power.about-to-expire timer. And that timer over here will be equal to a set timeout as well. And then that set timeout is going to take in a function. And that function will do something. After 3 seconds, we're going to go ahead and we're going to say this.power.about-to-expire is equal to true. So this timer will start and it'll say the power dot is active and it'll be blue. Then this timer will kick in after 3 seconds and say power.about-to-expire is true. Then when these 3 seconds are done, this one should probably be finishing up. And I'll go ahead and set power.active to false and power.about-to-expire to false. So our last thing that we need to do over here is say this.timers.push and push the power. I misspelled that over there, right there. So power.about-to-expire timer, and that will push that one on there. And then nothing will change right now, but the only thing we want to ensure is that our game does work. Now, one issue we're running into here is it's telling us that our for each over here is undefined. So cannot read property for each of undefined. So timers looks like it is undefined. So what we'll do is inside our constructor, by default, what we'll do over here is we'll say this.timers is equal to an empty array. And that will resolve that issue because that array doesn't exist. And now we're good. And we're just getting a favorite icon. If we had a favorite icon, we wouldn't get that little error there. To get rid of that fave icon error there that we see whenever we go over the audio there, what we can do is simply within the root of our project. So if you just click on index.html inside the main area here, and then click add file, we can just add a fave.faveicon.ico, just like they have right there, and then add that icon. Now, when we move, you'll no longer get that favorite icon error. Another possible error that you might see when it loads up, I had the sound disabled before for the Waka sound, is you get this DOM exception, play failed because the user didn't interact with the DOM first. Easy way to fix this one over here for Pac-Man, if we go down to the eat dot method, is we could just say, did you eat a dot? And this dot, we'll do say made first move. So if you made the first move, it'll play the sound. If you didn't made that first move, then the sound won't play. You won't get that error about trying to play sounds without interacting with the DOM. So Chrome is trying to do something smart where basically it doesn't want it playing sounds if you haven't actually interacted with the browser. That means clicking or typing into your browser window. Now that we've set up these new variables on Pac-Man for power.active and power.about-to-expire, we're going to be using those variables. So within our Game.JS, we're going to go and find our game loop and our enemies. When we draw an enemy, we're going to give the enemy a reference to Pac-Man. So with a reference to Pac-Man, the enemy will now be able to call Pac-Man dot power dot about to expire and power dot active. So within our draw methods, I just went to enemy over there and we're inside our enemy class. Our draw method will now have a reference to Pac-Man. And our draw logic will increase, and I don't want to put all of that code inside here. So what I'm going to do is I'm going to define a private method once again called setImage. And setImage will be in charge of setting the different image depending on the state. And that will take in Pac-Man as well. So it has a reference to those variables. So we'll pass Pac-Man in, and then we'll go ahead and implement that over here as setImage with Pac-Man. And then what we'll do is we'll go ahead and just cut that CTX over there and paste that into the image. We still also need to pass in CTX, so you can see by our error, CTX is not defined. Once CTX is defined, we should be okay. And there we are. Now our enemies are showing up again. Let's go ahead and use our Pac-Man object over here to determine whether or not the power dot is active. And if the power dot is active, what we're going to do is go ahead and change the current image. That's the one that we pass into ctx.draw. And we're going to change that to the scared ghost. Then in the else statement, if the power dot is not active, we're going to go ahead and change it back to our normal ghost. And we'll save that. And then as we move over those pellets, now the ghosts are blue. Then we'll just wait and see what happens over here. We can't eat them. And they changed back. So that is working. To get our ghost to flash blue and white when the power dot is about to expire, we're going to go ahead and add a timer. We're going to add the scared about to expire default, timer default. Then I'm just going to duplicate that line over here. So let me just copy that as well. We're going to put that over here, but remove the default and say that's equal to the default value. So now we have a timer that we can use when we're going to be flashing blue and white. Then inside the set images, we're going to refactor this because this code can get a little bit more complicated with a few more if statements, and we want to keep this method looking clean. So what I'm going to do is define a new private method. It'd be called setImage when power dot is active. And we're just going to pass in Pac-Man because we need a bit of additional information. Then what we'll do is define it over here with our other private methods. And we're taking Pac-Man in. Then we got what we're going to do inside here is we'll just do a little if statement. And we're going to ask Pac-Man if the power dot is about to expire. And then inside here, if the power dot is about to expire, we normally take our scared about to expire timer and we decrement that value. And then once the value of that timer, of the scared about to timer is equal to 0, what we do then is we reset the timer and then we perform an action. So let's just reset that timer over there back to the default. And then the action that we're going to perform is we're going to check if the image is currently equal to this dot scared ghost. And if it is equal to the scared ghost, well, we're going to flip it to the scared ghost 2, which is the ghost that is the color white. What we'll do in the else statement, otherwise, if it's not the scared ghost, or if it is, then we're going to switch it back to this dot scared ghost. We're going to flip between scared ghost 2 and scared ghost for these two images. And then the last thing that we need to do is if the power dot is not about to expire, that means the power dot is active. And if the power dot is active, at the bottom of this if statement, we'll just put an else, and that else over here will say this dot image is equal to this dot scared ghost, because otherwise you're just a regular scared ghost. Then let's go ahead over here, see what happens when we eat the pellet. After about 3 seconds, you can see they start to flash blue and white, and then they turn back to green. If we eat one power dot, and we're moving along and they start to flash, but then we pick up another power dot, you see it resets the ghosts. And then they go back to that blue state and then back to the blue and white flashing. Next, we're going to look at colliding with enemies, getting our game over and game win scenarios. So inside of our Game.JS, one of the first things we're going to do is go ahead and initialize a few properties that we're going to need. So at the top of the screen, I'm going to go define a game over equals false, a let game win equals false. And then there's a couple of sounds that we're going to pull into our project. So those two sounds that I'm going to pull into our project are the game over and game win sound. So let's go ahead and grab those both. And I'm just going to pull those in. So we have our game over sound and our game win. So let's go define two game audio objects. So we'll have game over sound is equal to a new audio. And audio always, as you know, takes in the path to the object. So game over dot wave. Oops, a little typo. And then to make this a little bit simpler, I'll just duplicate that line. And this will be our game win sound. And we'll just modify this to say win as well. We don't have any errors on the screen, so that means we must have the path right. If I were to modify one of those, you could see that we get an error telling us that the path doesn't exist because we get a 404. But if I put that back, it's all good. In our game loop, let's go ahead and add a method called check game over. So over here, we're just going to add check game over. And then check game over's job will be, well, you guessed it, to check if it's game over. So we'll go ahead and add a function, check game over. Inside check game over, what we're going to do is the following. We're going to check if it's not already a game over. So that's why we have this variable over here, because we don't want to check that over and over. Then what we're going to do inside that if statement, if it's not game over, we're going to go ahead and check if it is game over. That's another method that we're going to add. And then otherwise, what we're going to do inside here is if it is game over, we'll go ahead and play the game over sound. So we only want to play that game over sound once. You don't want to play it multiple times, just one time. So that's why we have this little guard over here. We only enter here if it's not game over, then we check if it is game over. If game over is true, then we go ahead and play that sound, and it's only going to play it one time. It'd be very annoying if it played it over and over and over. So then what we have is we're missing a function called isGameOver. And isGameOver is going to be determined whether or not we have collided with an enemy. So inside isGameOver, we're going to ask each enemy whether or not we have collided with them. So simply, we can do this by using a return statement. And we're going to go to all the enemies. And we're going to say, have one of you at least, that's what the sum method has, have one of you at least collided with Pac-Man. And then what we're going to do over here is we're going to check first, is the power dot not active? Because if the power dot is active, then that would mean that, you're not allowed to collide. You can't collide with an enemy then, or you can't be killed by an enemy. So if a power dot is not active, and we go ahead and we collide with an enemy, then it is game over. So we'll say enemy dot collide with, and that's going to be a new method that we're going to add. And let me just minimize my sidebar there. So we're saying enemy Pac-Man.power is currently not active, which means they're green. And then one of the enemies collides with Pac-Man. This will return true because sum is going like, is anything inside this list? And this list being our enemies, producing a true return statement over here. Something returns true, even one of them. Then all of a sudden it stops, returns true, and it is game over. Let's go ahead and implement the collide with method inside of our enemy. So within our enemy, we'll go ahead and go create this method called collide with. So opening up our enemy.js, Well, let's go ahead and set that function. I'm going to go set it after the draw, so it's one of the public methods that we have. And we'll open that up, and then back inside of our Game.JS, we see that we pass Pac-Man in. So we'll pass Pac-Man into that function as well, and save that. So that error message is now away because the collide with method is here. It doesn't do anything yet. The way this collide method is going to work is we're going to be checking this rectangle and the enemy's rectangle and seeing if they overlap with each other. The best example of collision detection is here on MDN 2D collision detection. So there's basically this kind of formula that we can follow in order to see if two squares are overlapping with each other. So in this example over here, when you move the square, it's blue, and as soon as it touches, that's considered an overlap. So we could modify this so that you only overlap when you're halfway through, so it's still blue over here. But this example shows as soon as they start to touch, you see that it turns that color. So we're going to use that same formula, and I'll link this in the description over here because this is a great resource for colliding with boxes, colliding with circles, so it depends on the types of shapes that you have. So in our example over here, we're going to be following pretty much that example there, and what we're going to do is we're going to say if it collides with Pac-Man, and we're going to say const size is equal to this dot tile size and divided by 2. So we're getting the size divided by 2. By dividing the size by 2, we're going to be able to check when Pac-Man is halfway on top of an enemy to check for the collision instead of having them collide when they're touching. Unlike this example here, they're touching. If we divide our size by 2, our collision will be detected when we're halfway over the other rectangle. And then what we're doing is we're comparing the enemy's X, and we're checking if it's less than Pac-Man dot X plus the size. So that's the number that we just calculated over there. And then it's going to be a few of these statements that we're going to have here. It's going to be on a couple of lines. So once we've checked the X there, we're going to do another check of the X, and we're going to say if the X plus 1 is greater than the Pac-Man.x, and then there's another one, so we need to check our Y positions, and then we're going to check our Y is less than the Pac-Man.y plus half the size, and then we're going to do an and there, and we'll say this dot y, it plus size is greater than the Pac-Man. I keep writing sprite because that's how I originally wrote the code, but I thought we would make it more towards Pac-Man here. And then dot y. So let's make sure that we got this right. We got our Pac-Man over here and that. So we're just getting an error right now because we haven't opened and closed and used this if statement yet. Once we save that, we're back to normal. So we're doing our this.x is less than the Pac-Man.x plus half the size. And then this.x plus, oh, there's a typo there that says 1. That would not work. This.x plus size is greater than our Pac-Man.x, and then we do the same thing with our y over here where we do half that size, and our y over here where we do half that size. So then you can see we're doing one side is Pac-Man comparison, the very same thing, and the other side is the enemy's side right there. So then if this is true, we'll just return true because that means we have a collision. Otherwise, we go ahead and just return false. We could do it two ways. We can do an else statement, or we can just return over here. So we'll just do an else since that looks a little bit cleaner, and we'll just return false. Then if we go back to our Game.js, you can see that we're colliding over here, and then it's going to determine if there's a game over. All right, let's go ahead and move Pac-Man and collide with an enemy. There we go. We just collided with an enemy as he went through me. And you heard the game over music. But the game doesn't pause. Let's go ahead and implement pausing the enemies and Pac-Man when they collide. So inside our pause method, we're just going to put an or over here and use that game over variable that we defined at the top of the screen. Then you notice that our enemies are currently reacting to pause and using it, but Pac-Man isn't. So let's go ahead and pass pause into Pac-Man. Inside the Pac-Man file, we're going to go use pause. So let's go to that Pac-Man file. And then inside the draw method of Pac-Man over there, we're going to pass that variable in. So we have our CTX, and now we also have a pause. And then we can go ahead and use that pause. So just like in our enemies, we wrap several of our methods, which Pac-Man uses to move around on the screen. We're going to wrap the move and the animate so that Pac-Man stops animating and moving. So we'll just say pause there. And we're just going to wrap our move and our animate. And we're actually going to check that it's not paused. So if it's not paused, then we can execute those methods. So let's go ahead and move into one of the ghosts. And now we got that game over music, and the game is paused. So this gives us an opportunity to see where we went wrong and how that enemy got us. All right, let's give Pac-Man the ability to fight back and defend himself by eating a power dot and being able to eat a ghost. Inside the game loop, when we draw our Pac-Man, we're going to go ahead and pass in a list of enemies. Pac-Man is then going to use that list of enemies to determine whether or not Pac-Man is able to eat a ghost. Let's go ahead and we'll add a new private method, and we're going to call it eat ghost. Just like our eat dot, eat power dot, we're going to have an eat ghost method. So that list of enemies that we just passed in, we're going to pass it into our draw method. And then we'll take that list of enemies and we'll pass it into our ghost list. Then we'll go implement a method called eat ghost, and we'll put that next to our other eat methods. Let's go over here and we'll go ahead and implement that over here next to the other methods. When we eat that ghost, we're also going to want to play a sound. So I'm going to go ahead and pull in another sound called eat ghost. So using that sound, we're going to go set up an audio object for that within our constructor. So within our constructor, we'll just go add that brand new sound. Doesn't matter where we add it, but we'll go ahead and call that eat ghost sound. And we're going to make that equal to a new audio object, and that new audio object will be in our sounds directory. And we called it eat_ghost.wave. If we save that, we shouldn't get any errors. And if we don't get any errors, we'll see that here. That means we got the eat ghost wave file properly. And then down below in our new method, eat ghost, we'll go ahead and implement this. Let's go ahead and say if the this.power dot is active, that's when we're allowed to eat a ghost. And then within this if statement over here, what we're going to do is we're going to figure out whether or not we are colliding with our enemies. So we're going to look at that entire list of enemies, and we'll just get back a variable called collide with enemies, and we'll go to that enemies, and we're going to use a little helper method called filter. Filter takes in a function, and that function will represent one enemy, and we're going to check each enemy one at a time, kind of like a for loop, and we're going to ask each enemy if we are colliding with them. So we'll call collide with, and inside the collide with method, we pass this, which is equal to Pac-Man. Then we get a list of enemies that we've collided with. We then use that list of enemies that we collided with, and we say collided enemies, and we loop over that list, and then we're going to remove those enemies from the game. So let's go ahead and do that. So each enemy over here that we got back. So this is all the enemies that have collided with Pac-Man, because who knows, two of the enemies could be on one square when Pac-Man runs into them. So we're going to use a method called splice. And what splice is going to do is it's going to modify our array by removing an item from it. To do this, we have to ask where that item is that we're going to remove. So we look at enemies and we find the index of, well, that current enemy that we're looking at. We pass enemy in. Then outside of that splice method, we say remove one item. Then what we do is if this is successful inside of this for loop, we're going to make this into actually a full-on method. So let's put braces right there around it. Then it'll be a little bit clearer. Save that. You can see our for each here. So first thing we do is we remove that enemy. And then after we remove that enemy, we play the eat ghost sound. So now we'll be able to eat a ghost when the power dot is active. So let's go ahead and give that a try. So Pac-Man, we're gonna get Pac-Man moving over here. Eat one of those power dots. Try and quickly get the enemy. As you can see, the enemy disappeared off the screen and it played a sound. Oh, and we got him too as well. Next, we're gonna go ahead and implement winning the game. Winning the game means eating every single dot on the screen. So in order to do that, we're gonna go to our Game.JS and kind of like our check game over, we're gonna have a check game win. So we'll implement that method over here. And then inside check game win, it's going to look very similar to the game over. We're going to use that same pattern of checking if the game hasn't already been won. And if the game hasn't been won, then we're going to set that game win variable that we have up here equal to our tile map. So our tile map is what knows if we won the game or not. The tile map knows about every single dot on the screen. It will be able to calculate and figure out whether or not we've eaten all the dots. So on the tile map, we'll be able to call did win. Autocorrect kicked in there, but did win. And then once we've won, we'll go ahead and we'll play a sound. And that sound that we're going to play is the one that we set up over here. So the game win sound. And all we have to do is call game win sound dot play. And then that sound will only play one time. Next, let's go ahead and implement the did win method, because as we can see over here, it's telling us it's not implemented. So we'll switch into the tile map file, and then what I'm going to do is I'll just put it over here. It doesn't really matter where. I'm just putting it with the other public methods. And we're going to create a method called did win. We're going to save that, and then the error message goes away. And inside did win, what I'm going to do is I'm going to create another method called dots left that we're going to call. And we're going to check how many dots are left on our screen. If there are no more dots left, that means that we've won. So if it's equal to 0, we're good. What I'm going to do now is I'm just going to check which number we use to represent our dots. So we used 0 to represent our dots. So now when I write the dots left method, I'm going to use that information. We're going to add a method over here that's private, and it's called dots left. What we're going to do with it is we're going to check the map and we're going to find how many dots there are and calculate that. So in order to do that, I'm going to use this method called flat. What flat does is that's going to transform our two-dimensional array. So we have 2 dimensions. We have array on the outside and then rays inside. So it's kind of like rows. And what this method does is it transforms an array. So I'll show you an example over here. If we had an array called, let's say, items, and items had 3 values over here, 1, 2, 3. Actually, that's not a great example. Let's say items had an array of arrays. So we'll have 1, 2, and then we'll have 2 arrays inside here, and then another array, 3, 4, and then an outer bracket. So now items, as we can see, is an array of arrays. As I expand that, it's got this array which has more items in it and this array which has more. Then I'll create another variable over here, and we'll call that flat array is equal to items dot flat. So when I call flat array now and look at its value, it made it into a single array. And items looked like that. It had 2 items and each one had 2 other items in it. So flat does this. So flat is going to make this into one big flat array, which would look exactly like this. If I were to remove all these things over here, that's what a flat array would look like. So let's put that back. Let's go down here and we're going to call that flat method. And then after flat, we're going to call filter. So we're going to filter our array down to only tiles. So each one of these represents a tile. And we're going to check if that tile is equal to 0. Then we'll get the length of that array. So this will let us know how many dots are left, how many items in our array are equal to 0. Then over here, if there are no more dots left and it's equal to 0, you've won the game. The other thing that we're going to want to do when you win the game is we also want to pause the game. So what we're going to do is we're going to go to our Game.JS. You can just select your Game.JS file. And then within our pause game, we are checking if it's Pac-Man hasn't made his first move, if it's game over, and we'll say if game win, because then you also want to pause when the game is won. So now if we give this a quick little test and we win the game, we go ahead and eat these ghosts to ensure that I win the game. And he's not gonna make it easy there. But let's go ahead. There we go. So got lucky. Now go ahead and just finish off all those dots. And there we are. And now the game is paused. I can't move anymore. Pac-Man stopped moving. It played the win game music. And we've won the game. Let's go ahead and implement that last part of the game that shows that either you have won or you have lost. So what we're going to do is we'll go into our Game.js, and then inside our Game.js, inside this game loop over here, we're going to call a function called drawGameEnd. And I'm putting it here on purpose because I want it to be after the tile map is drawn. And then I want Pac-Man and the enemies to be able to be drawn on top of the title screen. So that's the reason that we put this here, because the tile map will get drawn. This will get drawn on top of the tile map. And then enemies and Pac-Man will be drawn on top of the text. So very purposefully put here between these two methods. Then we'll go ahead and implement that method. We'll just put it here at the bottom of the file. You can put it anywhere inside that file. And we'll call that drawGameEnd. Now this function will only be executed if it is game over or is game win. And then inside this function, what we're going to do first is we'll set up some text. The default text by default, we're going to say will be you win. There's a reason I'm putting a space here, it just perfectly sets it up on our map. You can do more math and whatnot to figure out how to get text just in the right place. But for this particular example and this particular map, this works pretty well. However, if it is game over, we're going to change that text to say game over. And then what we'll do is we're going to do some drawing. So we're going to use our CTX. So in this file, our CTX is globally available to us. And we have our CTX fill style. We're going to set that to the color black. Then we're going to use a ctx.fill rectangle because we're going to draw a rectangle on the screen. We'll start at position 0 there. We'll get the canvas dot height. So for the Y position, we're going to take the height of the canvas, divide that by 3.2. So I figured this out ahead of time playing with the numbers. And we'll take the canvas dot width, the full width of it for that size. Oh, we'll change this to just width over here. And then we're going to use 80 for the height. And we can quickly see that if I lose, and you can see it played all our music, and you can see that Pac-Man and the enemies are drawn on top of this black area. Then what we're going to do is we're going to do some more CTX stuff to create a font. And we're going to use 80 pixels. And we're going to use Comic Sans. We'll save that. Then we'll go ahead and define something called a gradient. So at the beginning of this demo, I had some kind of neat colors and they kind of transition from one color to another, kind of like our purple background goes from purple to blue. So we're going to use another gradient here, but this is within the context of our canvas. Then we're going to use something called create linear gradient. And this linear gradient takes in a couple of properties. We won't go too much into those, but we're just going to pass in these particular values over here. Then what we're going to do is for this gradient, we're going to go add something called a color stop. And we're going to put 0 over here. And then we're using the color magenta. So if you just Google canvas text gradients, there's some really great examples on W3 Schools as well. but normally just play around with them. You can do some different colors and whatnot. So we're going to say at 0.5, go to the color blue. If we duplicate that line over here, we can then say, let's add red. We can say that color will go from 1.0 over there. So just kind of marking where these different colors will be. Then the last step that we need to do is we need to say that our fill style, instead of being equal to black, we would say that our fill style is equal to gradient. And then we can use ctx.fill text, and fill text, we give it our text, so which is either going to be you win or game over. And then we also give it X number and the Y number. So we say canvas.height divided by 2, is trying to place it in the same position as our little black rectangle that we drew over here. And then finally we click save. Go ahead and test that out, and by running into an enemy, and we get this nice little game over. So if we decided to just do something like the color white or whatever, and we ran into one of our enemies over here, we would get something like that. So you can see how it just immediately impacts kind of how cool it is to see the gradient color there. It really makes the game feel a little bit more professional than having the white text. And then we can also go ahead and win the game as well. Oh, he's not going to let me win. So there we go. So let's go ahead and win the game so we can get the you win text on there. So I've eaten both enemies, which makes it really easy now. Just need to eat the dots. You can also see from the movement that we implemented, it's really easy to move Pac-Man on the screen. You get the you win text. Could have put a few more spaces or something to center that text, but there you are. You get that nice little you win. And then optionally, what you could do after this is you could create more levels, change the tile map to a different tile map, increase the difficulty, make the enemies move more quicker. There are a lot of possibilities with this Pac-Man here and what you can do with it. If you made it to the end of this video, congratulations, you just made Pac-Man. I hope that from this video you've learned a lot of modern JavaScript, gaming concepts, and how you can use JavaScript to make games. If you enjoy videos about game development in JavaScript, using React, and just modern JavaScript in general, please like, subscribe, and share my channel. Thank you.